Can we all settle down? There are many seats here, so please come ahead. Guys, Vidhi, please come ahead. There are many empty chairs on the front. Please come ahead. Okay. Please let me know when we can. Okay. So, welcome to C City Conversations, and I want to say that this is the 24th cycle of CCT Conversations, and also the last event of last discussion of an year-long symposium that we have had around contemporary architectural practice in India, a millennial archaeology. And in this whole year, we have seen the distinct shifts that architectural practice in India has taken over the last 30 years, seen through the lens of the political economy and the shifts that have happened. And in this process, we have seen the transition of architectural practice into a corporate kind of model, the sharpening of conservation and heritage practices, the coming of environmental and sustainably green environment building practices, and such other kind of forms in which architectural practices have very sharply modeled themselves to cater to the market. Today is one of the concluding sessions of this, and I must say that we were not able to include many more strands of architectural practice in this whole series, of course, because we have limited sessions. But today's session we will inquire about computational and digitally driven practices. But before that, I must kind of give a brief introduction to what is CCT and what is C Conversations. CCT is the School of Environment and Architecture's outreach program. And CCT organizes events, lectures, symposia, and exhibitions in order to engage with the larger artistic and cultural discourses sphere within the city of Mumbai and outside. Our events are completely open to all public and are attended by a diverse group of people, including students, architects, professionals, academics, and sometimes also locals. And over the last 12 years, we have almost completed more than 220 lectures, talks with architects, artists, cultural theorists, performers, social scientists, and very diverse kinds of people. And the endeavor has been to expand and situate architectural discourse within a broader cultural and public sphere. And so we are very happy that we have come to the conclusion of this year-long inquiry into contemporary architectural practice, trying to situate it in the changing dynamics of political economy in our city. Um, my name is Anuj Daga, and I kind of coordinate the CCT events here. And this event has throughout been also partly supported by the Urban Center Mumbai, which is a node for dialogue, ideating, deliberation to carry out research and to communicate on urban planning, urban design, and urban conservation within the Mumbai metropolitan region. And with that, I want to give a short introduction to today's session and what we'll be discussing today. It is basically titled Computational and Digitally Driven Practices. And basically, the introduction of computers into architectural practice in India did not simply introduce a new tool, but it reshaped the logics through which architecture is conceived, represented, and produced itself. So, this talk will trace the emergence of computational and digital methods in Indian architectural practice, beginning with the early adoption of drafting and modeling software and then gradual transformation of architectural workflows that followed. Digital tools enable new possibilities of formal complexity, precision, and visualization, while also altering professional practices and design cultures. The presentations that we'll see today examines how the rise of 3D visualizations, renderings, and immersive media, such as artificial reality or virtual reality, reshaped architectural representation and the circulation of images within contemporary architectural practice. It also reflects on how computational design intersected with fabrication processes, introducing digitally mediated making through CNC technologies, parametric modeling, and experimental desktop fabrication cultures. These developments have influenced aesthetics, work cultures, and economies of production, while also finding strong tradition within academic studios and workshops. So, in this talk, we'll reflect on how digital tools have transformed spatial articulation, workflows, and design imaginaries themselves while situating these shifts within broader questions of technological aspiration and global alignment in India. And for discussing this, we have two thinkers rather. One is Krishna Murthy from Folds Design Studio, and other is Jinal Shah, who chairs the Masters of Computational Design and Fabrication at the CEPT University. And I will eventually invite Dushyant to moderate this evening's talk. But before that, I want to give a short introduction to both our panelists today. Krishna Murthy is an architect and the founder of Folds Design Studio, which is an architectural practice that explores the intersection of design, technology, and fabrication. Through the studio, he advances a design approach where computational thinking, material experimentation, and research inform the production of contemporary architecture. So, in collaboration with Anishka Mehti, the practice engages with emergent possibilities in parametric design, digital workflows, and advanced fabrication processes. Their studio is based in Navi Mumbai called the Forge Design Studio, and it has evolved from modest beginnings into a multidisciplinary practice, bringing together architects, designers, and skilled artisans together. The studio operates with an in house work lab equipped with advanced digital tools enabling the integration of AI, 3D modeling, and fabrication technologies within the design process. And alongside practice, Krishnamurti is an active educator and speaker conducting workshops and lectures on parametric design and digital fabrication across institutions in India. We welcome you. Um, and our second speaker, Jinal Shah, is an architect and computational designer specializing in the integration of digital technologies into design practice and education. She is currently an assistant professor and the program chair of the Masters in Computational Design and Fabrication program at CEPT University. Jinal holds a bachelor's degree in architecture from Kamla Raheja Vidyanidhi Institute of Architecture and an international master's in interior architecture with specialization in computational design from CEPT University itself. Her work centers on developing data driven, material informed, and fabrication oriented methodologies for architecture and design. She has led design studios, international workshops, and courses focused on integrating artificial intelligence, machine learning, and computational methods into design workflows. As the founder of her Shah Design Studio, she is actively engaged in research and development of tools, algorithms, computational workflows that optimize design, planning, and construction processes, bridging the gap between academia research and professional practice. So both our speakers come from very distinct spaces of practicing and education or pedagogy, and we'll see a kind of complete spectrum in the way in which computational architecture is kind of taught in within the space of the academy, and then how it is mobilized on the field. So, with that, maybe I can call Krishna Murthy to give his presentation first, after which we'll have Jinal Shah. So, Krishna Murthy. Yeah.
Hello. Uh, Good evening, everybody. I've got what, 15, 20 minutes? 40 minutes. Oh, that's lovely. I didn't know this. Oh, I thought 40 minutes for me. No worries. So quickly, I'll start with saying that, the practice of architecture is not just about the tools that we have been talking about, which are just softwares, but the kind of tools that I work with is completely different. Okay, so these tools are all completely machines. So, and these machines are not simple. They're all complicated machines. They're all digital machines. Everything runs with a program. So, where you need to learn CAD/CAM softwares, learning Rhino, Grasshopper, or other 3D softwares is very good and very intelligent enough to make models. But to execute them, you need to know how the products can be executed, right? By using tools. So, this is one of the first machines that I purchased. I got it in 2006. That is when I started my parametric modeling and designing. Okay, so it's a long way. It was a long journey. Made a lot of mistakes, made big losses in the industry to make sure that I survive for this long as an architect, especially in the field of digital design. Okay, so this machine is called water jet machine. Okay, so water jet machine is like a monster. It can cut any damn thing. So it can cut all the materials that you're looking at. On the left, I've written the materials. It can cut all the materials. Okay. Especially if we are looking at metal, it can cut up to 200 thick metal. Okay. So water jet is that a monster. And it cuts with water and silt, which we call it as garnet. Okay. Silt is zero point 0.2 mm, zero point 0.2 thick silt. That is sand particles with water with a pressure of 50 HP pump. You pierce through a nozzle of 0.3 hole, okay, and then cut this. And this cutting happens with parameters, which we call it as parametric. Okay, so if I want to cut a line, so it is X, Y, and Z. With respect to that, the machine is going to move. So whatever drawings that we make in AutoCAD or in your Rhino, we convert that, we take that drawing into our CAD/CAM tools, then write a program for that, and then communicate with the machines and get your product done. So if I'm looking at something like that, you can see it is cutting mirror. Okay, so water can cut mirror as well, which is just 6 thick. And just imagine the thin lines that you're trying to see. Okay, it can cut to that a thin line if you're using water. Anyways, now this is an outdated technology because recently, 3 months back, there are these laser machines which have come in which are cutting glass now. So you don't need water jet any further now because new technologies have emerged in now. Okay. So with the water jet machine, what we have done? We have done products, I mean the projects like this, where we have cut granite, tiles, your Indian Jaisalmer and created that kind of pools, details like this. Okay. What else we have done? I mean, this is like a parametric seating area lounge that I did for Bangalore Airport, where I've cut birch ply using a water jet again. So water jet can cut MDF, birch ply, Korean, glass, wood, metal, everything. Okay. So by using water jet, I've cut this. The best part in that design that you're trying to see is very important. It is just not a parametric design that you're looking at where we are saying that there are slices of wood which are stacked one above the other, right? But they are stacked not in a straight line, they're also stacked in a curved formation. You need to understand that. They are stacked in a curved formation. That means when they are changing their angle, then again, when you're trying to fix this at every junction, there is one detail that is attached, which we call it as a spacer. And the spacer has to be cut with respect to the dimension. Okay, if you see there, everything is changing. And that spacer is not just at one area, it is at multiple areas at one junction on one ply. That you need to look into. And at every ply, the spacer changes. And at every ply, at every level also the spacer changes. That you need to understand. And these are the things which we try and cut with machines, not with hand. Okay, there the tools are necessary to create this. It's a seating on the other side. It's a partition panel inside a TFS lounge at Bangalore Airport. Then you see a table base. Okay, it's a table base where we have cut metal in a tessellated format, made a detailed structural member inside it, cladded marble on top of that, and created that piece, which is like one solid piece of a marble. Okay, so that's what you can do. Then comes your CNC machines. CNC machines, of course, we all are aware of that. But CNC comes in multiple formats. It comes in 3 axis, 4 axis, 5 axis, 6 axis, and then the robotic arm, right? What does CNC do? Again, it cuts all the materials. Okay, it not only cuts, it also engraves. What all it engraves? Like it engraves, that's a 4 axis machine where it is engraving your lightweight concrete blocks. So you design something and you want to create a form out of it. You can engrave lightweight concrete blocks so that economically your products are done in a much better way. Then what else is happening? You're trying to use a double spindle. There are two spindles on one same, axis where it is cutting the same design twice. That means when you're multiplying, you want the same design to be engraved multiple times. Then to save your time, you have a double spindle machine. So that's where you can make sure that such kind of machines are used. Here again, a lightweight concrete block. I'm trying to cut a molding out of it. Then I'm trying to engrave a marble using a CNC machine. So what you're trying to see is these machines are trying to react to these kind of different materials. So you can play with multiple materials. And what are the thickness? You can see that concrete block which is 8-inch thick. There it is almost 2 feet height because the machine can engrave up to 1.2 meters. The bed size of the machine is almost 12 feet by 6 feet by 4 feet. So that bigger block it can engrave, right, with a 4 axis machine. And 4 axis machine is also about a rotary. Here what you're trying to say is x, sorry, this is x, this is y, this is z, then this is 4, right? But in a rotary this is the 4th axis. So you'll have x, y, z, and then the rotary. So we have to understand all this. So for every program, for every kind of design that you're looking at, you'll have a different program that you need to run when you're using CAD/CAM tools. So with the CNC machine, what have we done? We have built products like this. Again, this is one of the benches that I designed for TFS Lounge in Bangalore. So we have used just 3 ply to get this 12 feet table done. So we have stacked one above the other. We could have done using a CNC machine, but we did it with hand. Then we did a coating on top of it. It is done in ply. What does that coating look like to you guys? Right? What does it look like? Can somebody tell me? The black thing? Exactly, stone. But what is it? Stone on wood, but it is not a solid stone. It is a composite marble. Now, this is something which is a very different kind of a material which is available in the market, but people have not been using. We get artificial composite marbles in the market with a 20 slab thickness. But what we have done is we have taken the raw material, we have mixed multiple adhesives to a certain composition, and then we are trying to spray that onto a wooden log. So now this thickness depends upon from 3 up to 12 or 16 or 20 So that means you are actually making a composite marble, solid marble on the wooden form. Now this is the research that we try to adopt from the local materials which are available in the industry today. Just going to the factories, understanding what are the composition, what are the materials that they're trying to use to build their solid marbles. And this is what we did. So right now what we are also trying to do is we are trying to spray this composite marble from 1 on every surface if we are trying to work with wood so that we can protect our wood from the moisture. Okay, so that's how the whole bench looks like. So it's like a solid marble piece, but the inside is wood. So if I have to have a solid marble, it would be very heavy and it will be brittle also, right? It will break if I move it. Small accident, it will break. But since it is wood and on the top coating is your composite marble, you can build such kind of products. What else have we done by using this CNC machines? We have tried to create sculptures like that. Table, a log where I've cut it like a fabric, flowing fabric. Then the column again, which is a copy of a Ajanta Ellora thing. Then a column which is again a parametric design with your, again these blocks, these pine wood blocks which are placed in a different format. A table here, a door there. So these CNC machines give you the possibility to design and especially to build them. Okay, design is your thought process, but building, yes, the machines can help you out. They can guide you to exact precision that you can build your details. What else have we done? That's a spa that I'm doing where I've engraved kadappa, a local stone kadappa we have engraved into traditional details. That's again a Brazilian granite which I've engraved and inserted brass into it. That's a staircase. It's got a metal structural member inside. It's a cantilever detail, wood sliced into small blocks with respect to do a less wastage, and then stacked one above the other and then engraved it and created that kind of a staircase there. Again, wood stacked, engraved as if it is fabric. So all these possibilities are there for you if you're trying to work with machines. The only thing is you should know how to deal with the machines. You should learn what these machines can give you, right? You can design very easily in softwares, but if you want to build something using materials, that is something which is the toughest part. It took me almost 18 years now, and still we are making mistakes. Every day we have challenges, different challenges with different materials. So again, this is like a metal laser machine. So a metal laser can cut up to 12 thick MS sheets, but it can also cut your SS, brass, copper, aluminum. Again, to reduce your cost, these kind of machines can cut with air. You don't need oxygen at all. As architects, we are not aware of all this, right? If you're cutting with air, your cutting cost reduces up to from a 10 rupee per running inch to 1 rupee a running inch. That is something which we need to understand, right? And these machines absolutely run fast. Okay. Now this laser machine runs at a 30 kilometer per hour wala speed. Just imagine. So it's that quick and fast. And if you're cutting 1 to 2 up to 6 you can cut with air. Okay, you don't need gases at all. What have we done with this machine? We have done buildings like that. That's a residential building. This is again a residential building at Alibag, for which I have done a parking building just using 4 thick slab. Thin metal sheet. I have carved that, made that design. My whole slab is 20 thick and people can walk on that. Okay. That's a kind of a design that you can build. That's an interior space which I've done for IT lobby. This is an installation. These two are installations that you're looking at. So with metal, using a laser machine, if you have a laser machine with you, a metal laser machine, you can build these kind of designs. You can execute them to a precision. That is very important. Okay. Then you have a local regular CO2 machine, which we have been handling every time because we are making models. But are we just going to make models or something else that we can do? Panels like that, tables like this. Again, that metal thing that I've done, I've cut with MDF and stacked that. That what you're trying to see is a 120 meters model of Navi Mumbai has been designed and built on a site. Okay, that thing what you're trying to see is an actual model of Navi Mumbai, and it is 120 meters long. On the end, what you're trying to see is a glass. It's a solid glass. Layers of glass have been stacked to create a three-dimensional apsara inside. Okay. If you do a digital model and then slice that model, engrave each and every layer on glass. This engraving happens with CO2 machines, which we guys are not aware of. Nobody tells us this, that CO2 machines can engrave glass, it can engrave tile. This comes with practice and experience. Okay, if you're trying to work with machines, you need to practice everything, what how a machine would try to communicate with you, and this is all what we do. So again, you can become an artist by doing all this. Then we have got 3D printers. So we have got many 3D printers at my premise. The whole idea of having 3D printers, large volume of 3D printers, is to basically a smaller size, cut your model into multiple pieces, make sure that your complete model is done within a day, and then you can make things like this. That's a table that you're trying to see. That's a 3D printed model. Inside that model, we inserted reinforcement so that I can have strength to my structure. And then I have built that kind of thing. That's a table. What else have I done? So I've 3D printed all this stuff. This is all structurally stable. People can sit on that, stand on the chair, the wash basin, the bench, lamp, a chandelier, sofas. You can do any damn thing using 3D printing. For us, 3D printing is not just about making models. It's about going beyond, thinking how this 3D printing can help you out. Put reinforcement inside it, pour concrete into it. Put reinforcement into it, put composite wood into it. Put reinforcement inside it, put composite marble inside it. Put reinforcement, composite, lightweight concrete blocks, insert it. There are multiple methods to work with. The whole idea is you need to touch these materials, communicate with materials, understand how they're going to respond to you and to your designs. And this is all what we have made. Okay. Then comes your concrete 3D printing. Today, concrete 3D printing, for me, it is a big failure right now because I'm looking at concrete 3D printing doing these jobs, but it is not doing that. It's doing all these simple jobs. Okay. So for me, still in India, we are still doing research on a very basic level, but we are not that successful. Okay. Then comes your thermoforming machines. Now, thermoforming machine is nothing to do with digital architecture at all. There's nothing to do with digital practices because it is a machine where we make a mold. This on the left side, and it only works with two different materials. One is your Korean, the solid surfaces that we look at. The other one is the composite wood and the acrylics. Okay. or polycarbonates for the matter of fact, because these are the materials which can change its form when you heat them up. Okay, so that is a heating chamber, the left side one. The black thing you open up, you put your sheet inside, you heat it up, and then that thing is a vacuum. It's got a vacuum chamber. It lifts up to 1 meter height. It's got a 1.5 meter by 3 meters bed size. On that, you have to put a mold, and then you can create things like this. That's a mold. You suck out air and then create those kind of design details. So what have we done? We have done ceilings. We have done lampshades, making molds. So thermoforming is for a purpose where you want to multiply one object 1,000 times in a very short period of time. You can do all this stuff using thermoforming. Then comes your robotic arm. So right now what we are trying to do is we are trying to print with pellets. Okay, now this is a new thing that we have done where we are trying to print with pellets. So now the cost is reduced. The thickness of the layer is increased. In a smaller machine, the thickness is just 0.4 mm. Here we are going up to 10 mm thick, and the thickness 10 mm height, and the thickness is 1 inch. That is 25 mm. So you can go up to that extent today. But when you're going to this thickness in your composite materials, what happens is you lose your precision of the design detail. In smaller scales, you get precise details, but in this case, we have lost lot many details. The column that you're trying to see, it had two intricate details, but we couldn't print that because the layer thickness was more. So these are problems that we try to face when you're trying to work with machines. So on the left, what you see is something which we all are learning every day. These are the softwares: Rhino, Blender, Max, NestFab, Solid Edge. Okay. Then the lower one are those CAD/CAM tools, what you're trying to see. These are the tools which communicate with the machines. Okay. So the upper ones which we learn, but the lower ones, the lower four is something which we should learn if you really want to work with machines. Okay. And this is what all the softwares we are master at, but these four softwares that you're looking at, you have to become a master so that you learn that how you can work with different materials. Okay. On the right, those are the tools that we're trying to use in our factory. Okay. To execute whatever we are doing today. So coming to our projects quickly, there's a few projects. So that's a table that you're trying to see. This is from a sketch through a 3D model. We have cut WPC, which is wood plastic composite, into multiple layers, stacked them. If you see those pieces, every piece has got some rectangular cutout in the center. There are multiple rectangular cutouts. You need that because those are reference points. If you miss them on any of the sheet, you have to cut back again. Because if that is not there, then you can't paste it perfectly on one above the other. If you see that the pasting has been done in layers, then inside that hole that you're trying to see, you see that hole, through that we pass a rod or a pipe, okay, to give strength to my object, which is necessary again. Okay. So, and this was not one bench, it was a mirror image. We are doing two tables, 25 feet long. It was a 20,000 square feet of a lobby space, two A and B wing. It's a lobby, a mirror image. Only because with the digital help, we could get this thing done. So designing is part one. Part two is executing to a precision. Okay. And then that's how the whole product got executed. So what happens is you're also trying to integrate light into your object. It is not, in this case, we have integrated light also. Here it is, the material is WPC. In the other case, even this is in the same project. Okay, this is at BKC. Anytime you guys want to visit, see it, let me know. So this is again a separator from in your lobby from the baggage screen to the entrance thing. Okay, so that's a separator. In this case, I mean derived from corals. Again, we wanted to integrate light into it, but we thought we'll use a different material. So we thought we'll cut this into multiple pieces depending upon the size of the material we selected. The material was lightweight concrete block. So we divided this into multiple pieces, the whole thing into 144. Again, every piece is again divided into four pieces. So that's how the number of pieces were cut, engraved, numbered. It's a big puzzle. Okay. Then they were joined together to achieve that kind of a design that we are looking at. They're joined together, made sure that that's how the final object comes into process. Okay. So that's the screen which separates your luggage thing to your entrance lobby. So that's how precise the detail can be executed. On the top, what we have done is we have used H40. H40 is again a different kind of a material. This is something which people are not aware of. H40 is basically a binding material which is used to bind tiles to the concrete. Okay. But right now what we are trying to do is we are trying to use that material as an external plaster to my product. And that is something which people will not do. Okay, we are trying to experiment whether this material will act as a bonding agent or not. It will act as a plaster or not. So now what we have done is using H40, we have mixed marble powder. Since we are working with multiple materials, we mixed marble powder because marble has got little that glitter in it. So we've mixed that with H40 and pasted it. So we have got minor shiny particles here and there. So that's the kind of a design process that you can achieve by just working with materials. Okay, then comes again one more table. This is one of the most complicated tables. Of course, we have made a recent table which is in Onyx, but this was one of the complicated table for me because the 3D that you're trying to see, this is a 3D model. Generally, when we work in Rhino, what we get is we get a mesh on the model. That's the mesh that you're trying to see, which we wanted to keep it as it is on the model, and we wanted that mesh to be in metal. So inserting metal, and the black thing, what you're trying to see is stone. Okay, shit, what happened? So sorry. Alright, I'm so sorry. I think that it got deleted. Fine. So this is again a project that I'm doing at Bangalore. Uh, this is a theater that we are doing. It is a home theater. It's a complete bungalow in which I'm doing a home theater as well. So that's the theater. So the theater is at almost at a 60% completion. So the theater has got a bar, it's got seating, everything is like digital and everything is automated, AI generated. Okay, I mean everything will be working on AI internally. So we have completed a 60% of the project is done completely with acoustics. In this case, when you're seeing this as a design, can a theater have so much amount of wood? Right, it's a reflective surface. People will believe that this is not possible. You can't use so much amount of wood because there will be a lot of reflection. But what we have done is internally we have made sure that the acoustic panels that was designed internally, you can see a square grid. Every grid is completely different, filled with glass wool with respect to a certain percentage. Every box has got 30, 40, 50, 60% ratio of glass wool and some vacant spaces so that I can literally make sure that the waves, the sound waves, I can trap them inside. Okay, that's how the design was modulated. And we created this grid all over the space, over which we have the waffle on which we have tried to paste our flexiply on top of it to get my design as it is. Okay, so this is the kind of a detail that you can manufacture once your details are done. All this again by using CNC machines. So that's a small video that you can see. And believe me, this can be built. Everything can be built. Nothing is impossible now. If you can use tools in a much better way, especially the execution tools, all these CNC machines, robotic arms, if you are really mastering in it, then you can execute any damn thing. Then comes one of the projects which we completed almost 3 years back. So this we got inspired from that tree where we wanted to execute the same thing as a ceiling for an IT park. So it's again that 120-meter long IT park design that we had done where I made that model. So we made the sketch which acts as a banyan tree on top of the ceiling. Okay. And the best part is this whole installation was supposed to be suspended from the ceiling. And this installation was 80 tons in weight. So 80 tons suspended from the ceiling, that was the biggest challenge. Okay. So we made this model, 3D model as a design that we do. Okay. After doing that, we thought, why not print the model and understand how it is going to look inside that same space with respect to the human scale. So we tried to make that whole process very easy, understood that this is easily possible. Then we thought which are the points we have to plot those points from where we can suspend this whole sculpture. So we plotted almost 200 points in the whole space. Each point is suspended from a 6 mm thin cable, and each cable takes a load of 600 kgs point load. And that's the kind of a cable that we try to procure. Understood that these are the cables which are available in the market, and each thing can take a load of 600 kgs. And 200 points is what we plotted. Actually, we wanted only 165 points, but we plotted 200 points to make it extra safety. On the left, what you're seeing is the unrolling details. Then, to make our welders understand how these things are supposed to be welded properly, especially the joints. So we made these paper models so that they can understand well the joinery details, especially because when you're working with metal, it expands. So we made this whole thing there. We cut them in our factory, got them, took them to the site, and then fabricated them, complete that as a sculpture. Okay, so it's a 120-meter long sculpture suspended. You can see those cables, thin cables that you're seeing on the top. That's how the whole process takes place. From, if you have to make sure that your labor understands what you're trying to design, you have to make sure that these paper models are done in a very easy way, so that things can become easy. You don't have to run around, and these are all completely parametric modeling. They're not simple at all. To get these things executed, it becomes too difficult. Okay, so everything out here, what you're seeing is a 2 mm thin MDF. On those columns that we have done, we have just used 2 mm thin MDF to encase on top of that. That was a logo of our developer, so which we tried to cut and paste it onto the columns. 2 mm MDF comes for 5 rupees a square feet. Okay, so it's not expensive at all. So 5 rupees a square feet, 10 rupees a polish, and you're done. 15 to 20 rupees per square feet. Coating is done. On the floor, if you see, it is Kota. It's an IT park building. We used Kota. And the best part is Kota comes in multiple grades. That is A grade, B grade, and C grade. And C grade is the best quality. Okay, C grade doesn't mean it's the worst quality. C grade is the best quality. We try to make sure that we get the C graded Kota. Okay, and you can see the reflection in Kota. So it's the most complicated thing, but getting the Kota in place of one color. So here in this case, we got 90% one single color. Again, you need to search for it. Okay, it doesn't come easily. This is a bungalow we are doing in Bangalore. So I'll quickly run through just for you to understand. This is a 20 mm thin slab. That was the biggest challenge. Everything is designed in brick. The in is brick, the out is brick. Okay, the walls. So this is a completely parabolic roof. It's a simple bungalow. You can see a simple plan. It's a 4 BHK bungalow on a 9,000 square feet plot, courtyards. But what we have done is we try to make this waffle. We made the model, tried to create that waffle on site, so that on top of this we could fix my tessellated 6 mm thin metal sheets which we cut with our laser machines. Everything got welded, but when you are trying to weld them, there is an expansion, because of the heat there is an expansion, and that's where we couldn't connect. But there we had to do it on site then. Okay, so these were minor corrections which we understood while working on the project. So then we made this thing complete. On top of this, what we have done is we have cut 8 mm thin lightweight concrete blocks. Now this concrete block is acting as basically a insulation on top of that, which we pasted onto the metal, so that we can reduce the heat energy. Okay, so that the whole sheet on which we did this has been pasted by a 8 mm concrete block, on which again we have a 4 mm thin waterproofing. So that's how the whole thing is. These are the walls, the exterior surfaces of the building, again in a tessellated form. How do you communicate with your labor? This is how you communicate with them, by putting numbers on bricks. So we have given them that this brick, this number will be at a ½ inch from X reference, then 2 inches, 3 inches, 4 inches. That's how you communicate with your labor. And that's how the whole project got executed. And that's how it is. So what happens is, how, especially working with tools and working with softwares, it's very easy for us. But the labor who is working on site, how do you talk to them? And when this project is at Kolar, this is 70 kilometers away from Bangalore. Okay, so if you're trying to communicate with them and get these kind of projects done, it's not easy. And the interiors is this. Okay, so where we have cladded the internal surface, again an extra piece of insulation, which is pine wood. So it's completely a pine wood which we stacked one above the other, 8 feet long, 6 mm thin strips, and we detailed that in such a way. Okay, so that's how it looks like. So on the left, what you see is a thin sheet, 6 mm thin sheet of a slab, on which you have a complete 12 mm, that is 20 mm thick slab has been detailed out. Then again, this is the same IT park building where we have cladded the whole surface with brick, with completely different forms, different angles, each and every brick, just not horizontal, but also vertical. When I'm trying to fix a vertical brick, it is just 12 mm thin, a surface area which is getting attached to the wall. Okay, and this is a parking bay that where we were cladding with brick, a 2 lakh square feet surface area, cladding with brick and that kind of a design detail. It was the toughest part, but the best thing is the kind of adhesives that you're trying to use, the bonding agents from the brick. These are all high density bricks. We got high density solid blocks, designed a machine at one stretch. We can put 20 blocks, cut 20 slices of 12 mm thick. That's what we did here to reduce the cost, because each block comes for 36 rupees. Again, each block is cut into 6 thin slices. So you're converting 36 into 6. So it is 6 rupees per slice. Okay, and 1 square feet you need 6 pieces. So again, 6 pieces, that means 36 rupees. I've completed my work in for 1 square feet. So all this calculations is important. Parametric design, for many it may look complicated and expensive, but how do you make it economical? This is how we do it. Okay. So this is the kind of a design detail that went on to that building, an IT park building. Almost 6 years down the line, we dipped each and every brick. We dipped each and every brick into a nano coating material so that it doesn't attract algae. Okay. 6 years down the line, the building surface is as it is. There's no algae, no dust, nothing. Okay. So that's how it looks like. Internally, wherever there are these parking bays, we made these kind of jalis where you have a horizontal 12 thin slice, half cut bricks stacked in a straight way. Best part is, good thing is, in this case we had this east west sun path. So better was, we had a good amount of movement of the shadows inside the process. Okay. And the other thing is, because we used brick, we could reduce. After completing the project, we have realized that we have reduced almost 6 degrees of temperature inside this space, because it was a parking bay. Right. Inside a parking bay, you have got excessive heat. But fortunately, we reduced this 6 degrees of temperature. Then we realized at least we are trying to make some sustainable buildings. Okay. So earlier when we designed, we did not think about sustainability at all. We were trying to just play with the material. But because the material as such that it helped us out in terms of reducing the temperature. So now we started realizing whatever project that we're trying to do, we are trying to work out with bricks in such a way that we try and reduce the temperature inside the space. Okay. So that's how it looks like. So then these are again columns for you to just understand. I'll quickly roll. I think I'm very short of time, right? So these are columns stacked one above the other for a bungalow. Okay, this is the same bungalow where I'm doing the theater. These are 40 feet height columns stacked with your lightweight concrete blocks, then engraved and created to get that as an output. Okay. So then this is one project that we're doing at Andheri now, just a facade. We try to work with algorithms at the beginning and then try to make sure that those algorithms are converted or designed through AI. So we used a stable diffusion and try to create some kind of a design formation to get this is the language that we're trying to work with. That's the program to get this output as the project completely detailed in such a way that we have, wherever the glass is, that's the area where we have got lesser sunlight. Wherever there is a solid, we have got more sunlight. That's how the sun path was calculated to create that kind of a facade. So this is coming at Pandiri now. Then there is a staircase. This was designed by Andrew Spalfinger. So a very complicated thing, structural member, uh, 18 to 20 steps. He designed it, but he didn't know how to execute it. Okay. So he was an associate to Mad Architects earlier. Now he's working with Zaha. So he had designed it. We tried to build it. Okay. And build it with fiber, putting some structural member inside it. So that's how the whole design process went. That's how the design looks like. There's no support. You can see that we exhibited in an exhibition. There's no support. The staircase is still standing. We have not fixed it at the bottom. It's a cantilevered staircase. It's just a vertical pole. Okay. And you can walk on it. It's not just an aesthetical design, but it's a structural member. Okay. And this is the recent project which I designed, we have executed. So that's a bedroom. This project was designed for an architect only. Okay. So he just completed his architecture and he came back and he was too fascinated with the kind of designs that we're doing. So we executed this project for him. So that's the bedroom, a door handle. You enter in, there's a bed, the bed back, ceiling lights, everything. The digital modeling that we're looking at, 99% we have done by using 3D printing in this case. Okay. So the last slide. So the chairs, ceiling, only the lampshade, that the chandelier that you're trying to see is an ornamental chandelier. which we wanted to make sure that an ornamental chandelier can become a part of this organic design that we are looking at. Okay, so that's how we thought we'll end that whole project by just adding this ornamental chandelier into those living spaces. Done. Thank you.
Thank you so much, sir, for taking us, from the micro detail to the economics to the, bigger scale stuff that you're doing. I can already see that everyone is very inspired and thinking a lot. So I'm hoping that they'll ask you questions, and also Dushyant will open up more things. And I'll now invite Jinal Shah to talk about her journey. So, Jinal.
Hi, thank you so much for having me here. So, what I'm going to do today is I I am an assistant professor, so I work a lot with students. My work largely dwells around defining new design pedagogies within academics, but also those are based on the understanding of what the practice has been, how it has evolved over time, how digital tools are used in different ways. Like Mr. Krishnamurthy just told you the way in which he uses the tool. So every architect, I believe, has different ways and methods in which they use it. So, what I'm going to talk today about is I'm going to talk about digital technologies as a tool, a medium, and a co creator. Now, when I say digital technologies as a tool, what does it mean? It means it's an instrument to achieve a predefined goal. For example, I think we all have used AutoCAD. We've used SketchUp. We've used Rhino for 3D modeling, Photoshop to get renders, maybe used V-Ray to get renders of the 3D models that you've built in SketchUp, right? So in that case, essentially what we are doing is it's a linear process where we are the users. We are defining a set of commands in a particular order, which is giving us an output. Now, this output could be a drawing, it could be a 3D model, it could be anything. Now, it doesn't mean that these are not tools which could be used for computational thought processes, because sometimes we think that using a computational tool like a Rhino or Grasshopper is equal to a computational project, but that's not how it is. Historically, if you all might have seen this building, might have visited it, it's the Ahmedabadni Gufa by B.V. Doshi. Do you guys think it was done in 1995? Way before people started using Grasshopper or Rhino as a tool to build their projects. Do you think it's a computationally driven project? No? How many say no? You can raise your hands. It's okay. There's no right or wrong. Do you think it's a computationally driven project? No, I can see a lot of people say, why do you think it's not a computationally driven project? And those who are saying yes, why do you think it's a computationally driven project? You can be wrong, trust me. It's fine. One answer, come on. It's an interactive session. I don't want to give a monologue over here. Nobody? Okay, so I'm going to tell what I believe. We might have different point of views. That's completely fine. I feel it's computational. I would say a computationally driven project is not just about using a software or a tool, but it's a way of thinking. It's a way of defining forms, right? So, this, if you see, if I tell you to do it right now using Rhino or Grasshopper, you think it is possible, right? But it was done in 1995 when there were no tools available, but there were different mediums with which this project was built. There were, if you see on the right hand side, that there are drawings which are made through understanding of parameters, understanding of forces. If you've seen Gaudi's structure, where there are a lot of physical experiments done to understand how a form performs. The only constraint at that time was the availability of a tool, but it doesn't mean that there was no thought process behind it. However, during that time, 1900s was the time when AutoCAD started trickling in into the design process. People stopped hand drafting and they started using tool, but that tool was used as an end product. I had the form ready and was using AutoCAD to draft it, which is what I think essentially we all have been doing for so long. A lot of architectural practices also has been doing that. So here it means that we are using that tool as a means to an end. Like we are ending it with the tool. We are not thinking with the tool. But this project was still built with a lot of thought processes the way we are doing right now, where it was a ferro concrete structure. We had thin mesh, which was derived through computation, mathematical equations, and then it was built with unskilled labor. So it was still at that time, the tool was what was absent, not the thinking. Coming forward a little, coming to the 2000s or 2010, now is the time when we started having BIM, we had Rhino, we had Grasshopper. So now people started working with the tool, and now digital technologies became a medium where it was beyond means to an end. It was a space where thinking started occurring. People started thinking with a tool. Like, okay, this is what the tool is doing. Now let me see what can I do with the form. So there was an invisible conversation that used to happen. Now, this, I believe, is a more iterative process, could be used for form finding, evolutionary design, fabrication processes. In this case, you have a user. We define a set of rules or parameters, which essentially gives me a lot of iterations. Like if you've used or seen Grasshopper, it can give you 50 iterations or 500 iterations. We can evaluate each of this. If we feel they are not optimum enough, we can redefine the rules, or if we feel after optimization and analysis, it kind of caters to what my need is, then I will have an output and I can start building it. So while in the 2013, now this is the 2000s, we are coming a little decade ahead, where we have Zaha Hadid who started developing these forms using computational techniques. So that was part A, where things like this were happening globally. Simultaneously, there were universities and research labs which were looking at robotic manufacturing. Now, this was thinking with systems, thinking with machine in order to produce an output. For example, these are certain projects or pavilions which are done by universities like ICD and ITKE, where they're pushing the boundaries of material and computation, where you have thin birch ply, which is bent, cut with a robotic arm in order to build a 21-meter span structure. So this was to understand that how forms are derived through an understanding of material properties and fabrication processes. It was not a top down approach where I had a form and then I'm seeing how can I make it. I'm understanding what the machine has to offer. I'm understanding what the material has to offer, and then I'm seeing what are the forms that are emerging out of it. So these are some of the examples. There are many more projects like Knit Candela done by Zaha and ETH. So again, this was the era where there was a lot of research which started trickling into the practice. You can see these kind of thin timber wall structures made with thin 100 bricks or 50 bricks, and these are long span structures, 15 meters, 20 meters. It was all done through understanding of the physical forces and the material properties. Simultaneously, in the 2020s, now what started happening was we started using robotic arm for 3D printing, but it was not siloed from developing forms through an iterative process. So here, the machine and the machine as a sorry, the robotic manufacturing as a fabrication process came with an understanding of the form to develop the entire structure. If you could see, and if you see the project, it's an extremely interesting project because each piece was manufactured in a workshop, got on site, assembled, and it was done through understanding of the stresses. And because robotic arm enables you to do non-planar printing, like everything doesn't have to be on an XY plane, it can, your planes keep on aligning and at an angle based on how your form is stable. So here they achieved material efficiency and structural efficiency through the understanding of this process. Now, coming to the Indian context. So, this was all happening globally. Now, this was happening in 2010, 11, 20. Simultaneously, in India, we have projects done by Sami Padora. I hope you might have seen his work. So this is the Maya Somaya library. Again, over here, what you see interesting is it's a form finding process where you understand the principal forces which guide an entire long span structure. And it is done through those thin brick, it's a Catalan wall structure. So now your form is emerging through an understanding of the material. Simultaneously, in 2023, this is project done by And Black, which was the founders are Jwalant Mahadevwala. If you have seen the project, this is a Bloomdale International School. So if you see over here, the form was derived parametrically, but the construction was done using prefabrication processes. So again, because in India, we are labor intensive country. So we have to work with say semi-skilled or unskilled labor. So we look at computation in a different way where we are using it sometimes in a design process, but manufacturing happens through a lot of on-ground understanding and working with the laborers. But having said that, in today's time, and which I mean right now, 2020s, 21, 22 onwards, we are also looking at tools and technologies as a co-creator, where there is a dialogue between a human and a machine. What do I mean over here? So this is robotic additive manufacturing, 3D printing of concrete. So we have companies like Twasta Manufacturing Limited, which is a company in Chennai. What they do is they look at design from the perspective of what a robotic fabrication can do for us. So, and what they're also introducing, interestingly, is the aesthetics in architecture through a fabrication process. Like something like this might not be achieved with a conventional, can be, I'm not saying no, but what happens is it kind of, I would say, it adds layers. So if you see, there are projects like this, and all of these are worked in multiple ways. So certain projects are hybrid projects. What I mean is, part of it is constructed in workshop, part of it is constructed on site, and then they're assembled. So it kind of works as have you might have your prefab buildings. Similarly, they could work on certain similar principles. So essentially, what we are trying to do, and this is all happening in India right now, we are looking at digitization and automation of design and construction as a whole. We are not looking at construction or making as an afterthought, but we are looking at it simultaneously while we are designing the form. So, and as you can see on the right, can you see like it has this aesthetics which otherwise might be a little difficult. I'm not saying impossible to achieve, but a robotic additive manufacturing makes it, I would say, a relatively easier to achieve. This is again project by Sameep, where now he is also looking at form as kit of parts, like it's an assembly system because every machine has its own limitation. Say, for example, a robotic arm can print 3 meters by 3 meters or 3 meters of volume. So your entire structure has to be discretized into parts based on the understanding of its structural stability, and then it's assembled on site, or it could also be printed on site. There are multiple ways in which you could achieve it, but we are changing the lens with which we are looking at architecture and form, and understanding how it's also informing the spatial quality and the spatial relations within the structure. So these are some of, and if you could see the way you are representing your drawings is also evolving over time. Like you saw the drawings that were done in 1995 to the drawings which are being done right now. It's changing because there are certain drawings which are to be read by the machine to print. So there is a set of drawing which a machine is going to read. There are set of drawings which your client is going to read, and then there are set of drawings which your laborer is going to read. So there now you also see that there are multiple agents with which we are coordinating, collaborating, and producing the work. Now, so this is all I would say design and construction. Now, let's not forget AI and ML within the visualization process, because it's again changing the way we are communicating as architects and using the tools. So in this case, we have a user. I think everybody's used ChatGPT, Midjourney, DALI, Gemini, Nano Banana. I'm sure in parts for some tasks you might have. So we have a user. We as humans, we define a task. The machine evaluates it. It evaluates based on a trained data set which it has. It predicts, it gives you an answer. For example, if I ask ChatGPT, what do you think the weather of today is going to be like? It will give you a prediction based on the data set trained. The human interprets. And then if we like the output, yes, we use it, or else we will redefine the task again. So now this is being used with Gen AI tools. As you can see, people like, if you've seen works by Tim Fu, where they are using a crumpled paper, there is a data set trained on the language that Zaha Hadid uses for their architectural forms, and you write a prompt. So now this is called as prompt architecture. The way we define ourselves as architects is also changing. My job is not just how to know how to make a plan section elevation, but if I want to use a tool, I need to know what is prompt. So there's a term called prompt engineering, prompt architecture. So there are these new positions which are coming up within our practice and within our field. So this is also some of the works by multiple. So this is very interesting. I find it's done by Kedar. What he does is he's used Grasshopper to develop the parametric form, Rhino and Grasshopper, but used Comfy UI and Nano Banana to visualize how the form would look like. So imagine we are eliminating the entire process of digitally modeling it by, adding 1111 command. Like, for example, if you know bits of algorithm, and then you put it into Comfy UI, you will get a visual. Now, this is changing, I would say, the practice in a way, the way we communicate with a client. It would initially say what would take me a week to pitch a project might take me 10 minutes if I'm really good with my prompts and my tools, or maybe half an hour. It depends on how skilled we are. So, and that was visualization. Again, this is, we have Autodesk Forma and Finch 3D, which is absolutely changing the way planning is done in architecture. Autodesk Forma is trained on a large data set on environmental analysis, on what the kind of weather patterns would be. And Finch 3D is a library of plans. So it works on adjacency rules. So what you do is, imagine I make a rectangle, put it in Finch 3D, it will give me an entire plan generation with furniture. What is the area? What should be the door? Where should be the door? If I start changing it, it's absolutely giving me 500 iterations in, say, half an hour. So, and now Finch 3D is also kind of doing it. It has, I would say, it's using the Rhino and the Grasshopper API. So we can make parametric models in Finch 3D. I think these are the tools. So there are multiple tools like that. I'm sorry, I've not added it over here, but there's a tool called Raven.ai, which makes Grasshopper scripts for you. So for a beginner, it is also changing the way we learn a tool as an architect or as a designer. Now, what it does to our profession is a question which I don't think any of us has an answer right now. But if you can see, it is telling me, okay, if I want 2 bedrooms, if I want 1 bathroom, and it will start generating plans for me. And this was a video which was done long back. If you see the videos right now or the actual tool right now, it's much more efficient, and it's used a lot in real estate right now. Maybe not by architects or building institutional projects, but if you look at commercial real estate, this is very efficient design process. Again, this is another which is Archigan. Like if you see, I'm just making an outline. I have defined what colors, and it's generating multiple, I would say, layouts within my boundary. Now, all of this is done by training data set. I can have a data set of 5,000 plans, which as and profession we have over past 100 years. It's trained on it, and it's giving me outputs in seconds. So what I believe is, call it practice or pedagogy. I feel we are moving, or we've already moved from drafting to algorithms. From tools, we've started thinking about systems. From defined outputs, we are looking at emergent processes. And from human only, which was initially an architect was the author, now it's become human and AI. So this is how we are, I feel, transitioning over time. And of course, this is still like an ongoing thing. So now all of this this is what I have been, I would say, reading about, researching about. And when I started the program at MCDF, every architect or every computational designer has their own vision or something that they believe in. So the program currently was based on the conversations that we've been having at CEPT. And the thing that I have been thinking over past couple of years, and the questions that I've been asking is, can architecture move behind the design of objects towards design of interdependent systems? When I say interdependent systems, material systems, structural systems, environmental systems, spatial systems, I can list 10 and I can see what are the cross relations between it. So, can architecture move beyond? Can it move beyond designing plan, section, elevation, and then making? When I mean objects, I just think of it as a final form. And as architects, are we merely users of digital tools, or can we become creators of systems that shape design? Mind you, Finch 3D was actually developed by architects and not engineers. That entire, because as architects, we inherently know what the adjacencies are or what the spatial systems are. And then there are tools which enable us to do that. So I believe there is that we should design through and design of. So I believe architecture, or in this term, I would look at it as design through and design of interdependent systems. So this is what becomes like a premise of the program, where we also look at an integrated approach, where we look at a system, fabrication process, and material as a whole, and not in different silos to be seen across a design process, but at every point we look at it as a whole. So here we are looking at material driven and computational fabrication. We look at material innovation, systems design, optimization, efficiency. We are having dialogue with the digital tool. I reimagine design as a laboratory of advancing material systems. So these are a couple of examples. I know it's too late. I'm not going to kind of get into detail of all of it, but systems like 3D printing on a stretchable fabric, which enables me to achieve lightweight systems. Now, this could be used as facades, products, building systems, XYZ. We develop our own computational workflows. We test. So again, it's a combination of physical experiments and digital experiments to understand the efficiency of each form. Along with this, we also work with biomaterials. So this is something which we have started at CEPT, where you might have seen people. I don't know if you've seen reels on Insta. Sugarcane bagasse is used for developing boards. You are using rice husks to make, because we are looking at sustainability. We are looking at how do we reduce waste. So we are looking at material driven projects, and this time we looked at biomaterials. So we have something called, so if you see the bottom right image, actually that's made using sawdust, which was produced in our workshop. We added guar gum to it to make sheets which could be used for XYZ applications. Worked with loofah, mycelium. So again, material systems, system driven projects. We look at optimization and analysis. This is done through digital medium. And then again going back to physical prototypes, it's also an iterative to and fro process of how you would use what tool at what time and what medium at what time in a process. So looking at assembly, disassembly systems. So these are some of the outputs that we have achieved over past years. Again, looking at clay printing. So looking at how we work with machine, understanding the parameters, constraints. Now, each of this, you see iterations over here, they were developed as a response to the environmental criteria and the phenomenologies that a student had defined. So I think I'm just going to run past this. Again, looking at facades as series of modules which could be mass customized and mass produced to look at evaporative cooling systems. Again, looking at getting inspirations from biomimetic principles and then translating it into physical forms through clay 3D printing. And last but not the least, we also look at robotic additive manufacturing. It's a collaboration with Twasta, where we also, it's again, we are looking at architecture practice as a research, industry, academia, and a research initiated processes. So students developed a lot of iterations, projects. They went on site with the machines, tested what works, what doesn't work, reiterated the digital models, and then actually printed it. So, just a quick glance. It also helps us understand that what is the scale we can achieve. So, some of these walls were as high as 2 meters at an inclination. So, resolving the form for its structural integrity. and understanding, how the digital informs the physical and vice versa. So this is all work done by the students. I'm going to skip through. So I would like to last two slides. I would like to end with what Carpo has said in the book Second Digital Turn. In the age of computation, architecture no longer needs to be designed as a single fixed object, but can be scripted as set of instructions for generating many possible outcomes. So from looking at mass fabrication or mass production to mass customization, which is what the technology is enabling us right now, and going forward, I believe from adopting tools, this is as architects or designers, from adopting tools, we start building tools. From rule based design, we look at data trained design. A lot of this is helpful even when we look at urban planning, not just building as a form. And from defined procedures to looking at predictive modeling. So I would like to end with a quote which I love the most, which is by Cedric Price, that technology is the answer, but what was the question? So as architects, we have to question that what does technology mean in practice and pedagogy? Because it's not one framework where everybody has to fit in. Everybody of us can develop our own methods and methodologies to achieve multiple things based on how we use the technology. So yeah, thank you.
Thank you so much, Jinal, for tracing this entire history and locating your own kind of pedagogic practice in that. It was very helpful, and I think today's two presentations have been so well structured and informative that I'm really looking forward for the things that Dushyant will open up. So I invite Dushyant along with our two guests for a short conversation.
Um, Hello. Yeah, thank you so much. A lot of um, intense work and intense presentation. Actually, it provoked me to then open it up with a few things which I had, somewhere in the back of my mind. And I would like to, I mean, what it reminded me, I mean, especially the presentations which were there, it brought me a flashback of Frank Gehry, who was tracing the model of the Disney concert hall, and it took me to that time, and then it brought me back to uh, the other things that followed after, wherein I think in the early 2000, late 90s, early 2000, there was a lot of work which was going on across the world, right? Where digital was just starting, the data models which are being made. There was this whole particle theory that was coming up. And after all of this work, all of that digitally produced work, uh, the problem was how do we make or how do we construct? There was this whole problem with the single surface, right? And like then the question was how do you break it down, or what kind of a tool that you make that will be able to produce or construct the design. And that's exactly where this in the discourse of digital architecture is where this fabrication really took um, the first steps in some way or the other. Um, so opening from there, I think, and then coming back to today's two presentations, and both of you opened um, with tools, like tools of fabrication, tools as the one that thinks, or the tools as the one that produces. So I think if and especially in our context, I think the tool became quite important. And I just want to make a comparison where tool is also somewhere very closely embedded in our cultural, say, ways of life. Like to make things like we make a lot of things for our own selves. Like if you go beyond the cities, I think you'll find a lot of people making their own things. They have their own tools, they customize it. So I think tools have very special place in our context, in our say in our country especially. And I think tracing contemporary movements within India, just to give a context to everyone, I think I am a decade younger than him and a decade older than her. So it just kind of to trace. No, my reason to do this is to trace or to kind of put the work in context for all of you in terms of where I'm coming from and the kind of things I'm bringing as discussion points, and also I think what both of you brought, because what I can see, there's a very intense work that you bring in with knowing tools, like, and taking complete agency of making, right? Because I understand there was a big problem when the digital tools came in. What I remember very strongly is the CAD that came in over here is through CAD centers, everywhere. At every railway station there was one CAD center, and I think all that we did was learn tool as a you can say reproduction of a drawing, like draft. So I'm just going from there to when I remember you telling me just now that you got a first water jet machine in 2006. So I mean, just briefly, if you could from your own histories, say, how did you enter this digital question? Like for some, like for example me, it was through my postgrad education. For you it might be some other means of even for her, I mean, she has done a postgrad, but then how did you enter into this? Because there is always a gap in which how you, like, from where you did your masters, or when the bug hit you or the bite you, and then how did you enter and how did you take it ahead? So before the tools and before all of this, like, what fascinated? And I think because that will just place us for the next set of discussions, I think.
Yeah. See, I completed my architecture in '97. Just came out when AutoCAD just entered into our education system. So final year when I was giving my thesis, I had few of the students who had done presentations in AutoCAD. Okay, and we were like, "Ye kya hai?" I mean, we are just using set squares, T squares, and making our presentation drawings. And this guy comes and does some floral patterns, some details, walls filled with hatches. But I mean, it was like a magic to us. So it was too difficult for us to absorb at that given period of time. Drawings can be made like this. But, and also, when you're sitting on a computer, can we really learn this? I mean, that is also a question. Many a times, when you're sitting on a driving seat, right? एक driver को एक the steering wheel, then the gears, then the escalator, then the brake. All this he has to really calculate at one given period of time and then drive. And also a person has to literally understand how the engine is actually breathing. Okay, so I love driving a lot. So I learned lot many things from those aspects. So what I'm trying to say is uh, in the final year, I thought that to learn AutoCAD or to change my tools that I need to use to move forward, I need to literally correct myself at every given period of time. So 3 years down the line, 97 to 2000, I literally worked on understanding what this AutoCAD is, and I learned it in such a way that I used only 12 commands in AutoCAD to complete my drawings. Only 12 commands. I don't need anything else. If I need to make my working drawings, my plans, my elevations, or even 3Ds for the matter of fact in AutoCAD, especially the perspectives, which we used to draw with lines, that also you can make it in AutoCAD, okay? Because it's a two-dimensional format. So for me, the screen was just a paper, and I'm just trying to draw things, and that's how I learned. But in 2000, I came to know that architectural practices is not only about an architect, but an architect will always have a client for whom he is designing. Then the client will have set of contractors who are always with them and not we. Okay. And the contractor is always there to tell the client, sir, ये architect सिर्फ सोचता है लेकिन बना नहीं सकता है. And he is the guy who's going to make it. 24 hours, this guy would be brainstorming the client. This is what I faced when in my initial stages. Okay. So that's when I learned that architectural practices is not just about one person, but it is about collective people. At the end of the day, I am going to design, my client is going to fund, my contractors are going to build, and my contractors again will have layers in it. An educated contractor, then a subcontractor, then a supervisor, then a labor, and in the labor also you'll have four categories. एक main mistri, second mistri, helper, or just join किया हुआ. All these things, all these people are actually going to execute my design. Okay. And I have design thinking by ये सब तो बना दूंगा. And we have this set of people who are going to build our products. Okay, and build our designs. That really gave me a challenge that यार कुछ करना पड़ेगा life में, because architectural practices is not easy. मुझे खुद को ही उतरना पड़ेगा, because even in college I used to make my own models. Okay, models हम सब बनाते थे, but I also used to make models where I used to sell models. मतलब developers के लिए मैं model भी बना के देता था. So I'm very passionate about making models from first year itself. सीख गए थे हम लोग. तकलीफ था तो सीख लिए. Then slowly I understood that I need to take something else into my system, and take that thing means it is a machine. And when did I get this machine? In 2006, as I said to him, is only because I wanted to do some inlay pattern for my project where my client was spending almost 6 lakh rupees, that is 6,000 rupees a square feet, for 100 square feet of an inlay surface. Okay. 100 square feet का inlay करने के लिए I had to spend 6,000 rupees a square feet for two different marbles inserting into one each other, right? And this machine, this person was doing this project, was there at Meerut in Delhi. Okay, I had to send my marble from here, transport it out. He engraved this and then he shipped it back. And believe me, we are very bad at packaging. Indians are very bad at packaging. The product that came back to me, 30% was broken. So I had to send back materials again and then get the product again. So for me to complete this 100 square feet, I had to spend almost 10 lakh rupees. And my client was there ready to spend because he's getting some inlay project. Okay, some detail that he's getting. At that given period of time, after completing the project, I realized that I paid 10 lakh rupees only for 100 square feet. Where is this machine? What is this person and how is he working? So I had to go back to Delhi, sit in this place and understand that there is a machine called water jet machine, and an operator is needed to operate this machine. There is a tub on which there is X, Y, and Z. All this are used by using a pump and a chiller plant. Okay, a RO plant again. All this is needed, and technically you need to learn this. And I don't have to learn. There are people who are going to come and teach me along with the software. That's it. And it costed me a bomb. Okay, that given period of time in 2006, it costed me a bomb. I came back to my client. I just tried to approach him in a very short way, saying that, sir, 100 square feet का काम करने के लिए 10 लाख रुपए डाला है. अगर हमें 300 से अगर 1000 square feet करना है, तो opportunity है, and you are a person who can spend. So I just gave him thoda sa lollipop, saying that you can spend. So he said, कितना लगेगा? So I said 60 lakh rupees लगेगा in 2006. He said, Krishna, are you serious? मैं बोला, हाँ sir, I'm serious. 2006, he gave me 60 lakh rupees as an advance. I got this machine. I put this machine on site, and the swimming pool project that I showed you, that is a 20,000 square feet project. I did it in 350 rupees a square feet. Just imagine, from 10,000 to 350 rupees a square feet. And that's when my first machine came into my office. Site complete हो गया, client को machine से कुछ लेना देना नहीं. I got the machine back from Bangalore to Mumbai. मेरा factory वहाँ शुरू हुआ in 2006. Today I've got 150 plus machines in my factory. Every machine that is needed to cut any material that is needed to practice architecture in interiors, I have them in my lab. Okay, so I made sure that it is there in my lab. Whatever fees I get, I don't put it onto me. Only since last 2 years that I'm trying to put it onto me. Otherwise, for last 28 years, I accumulated my money and put it onto my machines. I got my machines into the space. So whenever people ask me, आपके ऑफिस में कितना स्टाफ है? मैं बोलता मेरे ऑफिस में 10 से 15 स्टाफ है, but 150 मशीन है मेरे पास. So that is important for me today. So machines can literally build, because see, doctors, until unless he doesn't perform his own operation, काम नहीं कर पाएगा. Artist खुद का painting बनाना पड़ेगा. As an architect, we are designing someone else's building for us. And that is something which was not acceptable for me. I thought I need my machines, I need my perfect drawings, I need my perfect execution details to be done on site as it is. So that's how everything went on. And today we are here. Okay.
Jinal. Yeah. How? Yeah.
So I think I still feel I'm pretty young to kind of have a very long journey or a history. I still remember I graduated in, okay, am I audible now? I graduated in 12, like every one of you hoping sitting over here. I was like, one day I'll be this great architect, build some 10 amazing projects. Like we had studied B.V. Doshi, we had studied Lee Cobb and all of them, Louis Kahn. And I was like, someday we'll make a mark like that. And started with normal joining an architectural firm. And trust me, I got bogged down by making real estate projects because at the end in Mumbai, all I could do was make residential buildings, which were these FSI driven projects. Um, and then one day, I don't know what happened, there was this 360-degree conference in Mumbai. I still remember it was in Jan 20, I would say 17, yes, 5 years afterwards, 2017. Then Patrick had come over here, Cecile Belmont had come over here, and they spoke about parametricism. And it kind of opened up my idea of what architecture means in this age, in this time, globally, what's happening. And that's when I actually decided to do the post graduation because I felt that architecture is more than what we are doing right now. And I always thought of it within the Indian context. So I also wanted to understand that what does parametricism or computational design mean? Being in India, we are very craft oriented or a labor intensive country. Like if we start thinking of machines replacing humans, that's going to be a huge challenge in a lot of other ways because that's not possible. So that's when I decided to do PG, but that too also from India, because I wanted to understand how do we start adopting these design processes within the context that we are situated in. And that's when after doing PG, I started working with what are the avenues within the existing design process there we can start plugging into our knowledge base and our knowledge system. Like how is it that you actually start efficiently using grasshopper? What are the new material systems that would also survive within the Indian context? Like if we see, there are a lot of projects which are done globally, but when we look at it from how much could it be produced in India, it's not as viable a solution as that is. And that is when I started working with it. And as and when I started going ahead, I realized that tools are just not ways to reproducing your ideas, but actually tools are what also gives you new ideas. Like that's when started working with multi-objective optimization tools, and now looking at AI and machine learning. So now I can feel it's a whole circle back. Like when I look at tools like Finch 3D, Hyper, which is a data driven thing, I also feel that within the Indian context, where actually our real estate also defines our skyline right now, there is an immense possibility as an architect, I feel, to intervene in the right way, develop these, I would say, use machine learning in a sense which kind of is applicable for us, looking at rule generative design projects. Like, like how do we start redefining our methods of working is what has been my journey, and which is what I'm aspiring to do going.
Thank you for taking us through your journeys. And I think how did you enter? But I remembered in 2000. I mean, from what my memory is, 2010, 11 is when I was seeing a few movements around this field, like from like Sameep just picking up his practice back then, and I think there was a shift within all the people who really started a very serious digital practice. In terms of what I mean by digital practice is where they were exploring spatial questions through digital tools. And I think in a period of time, I think that the spatial question then probably took a more traditional location or space, and then the making or the tool became the more exploratory medium for us to test things out. And I want to draw a comparison between two ways of thinking about space. Now one is where if you remember a load bearing construction is limited to the size of the available resource materials. Like the wood is available at a certain length, or stone is available in a certain size, and then you can build accordingly. Um, and then you start thinking, or the spatial logics develop through those making processes. Or you know that the concrete has a certain limitation of casting, or it has so you start thinking of making from those factors or parameters. Now here, once we see what you have done by making through digital tools and also other machine assisting machines with that, and in your case I think you starting from digital tools, then you kind of breaking it by mixing it with other new materials, like there are these biomaterials or clay, or like using concrete completely differently, like without a cast. So like there has been a long shift in terms of right from the spatial exploration to actually the making the tool as a generator of a new logic to think about space. Now I'm trying to kind of locate the question here, or push it in a direction where what load bearing techniques made us think about space, of how do we structure a logic or a grid. Now what are the new ways to think about space with these existing tools? I think you've worked extensively with those tools now. So what probably would be the spatial directions that one could start exploring? What will be the new logics of space that we could say consider, like from the works, or maybe from something that is all you are speculating in your mind? Like where would we see that? I'm not thinking speculation in terms of how advanced we are, or how what AI can do. I'm thinking of speculations of what it does to the space, or how do we start inhabiting space through these tools. So that's where the question is sort of located. So I would ask any one of you to respond.
So I can say from the pedagogical lens that we have been looking at, I have not done, like I've not been in practice to give you the answer about how it's been adopted within the practice. But of what I have started seeing these tools doing is, like I said before, that now we don't look at space as a separate element. Like I still remember initially what we used to do is make a plan, see to it that whether structurally is it stable or not, give it to an engineer, and then define, okay, what would be the interiors of it, or how would the elevation look like, or so there was a linear process, I feel, at that time. But in today's time, when we are looking at it from a systemic perspective, so we can always look at space as a correlation of how a form can define a space and a space can define the form. Also, each material, I feel, has its own quality which could evoke a sense of the spatial nature, like looking at adjacency. So, for example, if I can give you an example, if I were to build a structure using timber as a material, as against if I was to build the same structure using concrete 3D printing as the material, the way the space would be defined could also respond to the kind of material or the system you're working with. Because when we start looking at material property, like if I'm using wood, it will have certain mechanical, physical properties as against concrete as a material, which initially used to happen as an afterthought. So now what happens is, okay, if I want to use X material, my space has to be of a certain size, a certain ratio. So we start thinking space also as a numerical way of working rather than it just, of course, it's a composition, but also it's a numerical composition with a lot of systems working together. So if I want a long span structure, I know that it is possible using ferroconcrete. I can get a 20-meter space. So then it's a big rectangular or a square space. And then whatever I want to do with it, I could do with it as against traditional ways of construction, which is a beam column and a slab kind of a construction.
So I just want to bring, like, with this point, the example that you took with of the Sendoshi Gufa. Like you there you mentioned that the tool was absent, but not the computational thinking about how that was made. So like just to like in what you're mentioning right now, that how you can think or kind of bind the material itself in the designing process,
Yes,
instead of it appearing later in the
correct.
stages. But more than that, I think I want to maybe think of the proposition that you made as tool as a medium
Yes.
of thinking. And then so for example, as a speculation, what would Hussein Doshi Gufa be today with the tools that we have? Like in terms of, I'm not exactly asking you how in that sense, but
Yeah.
but what kind of a trajectory would that process take?
So if I can talk purely from a process driven system, so usually say how we could look at it is we look at form finding techniques in which if we start defining the material, imagine Hussein Doshi, sorry, the gufa to be made of timber. Then I would start fragmenting it into triangles because timber inherently is a planar material. So if I want to use economically, I want to produce it economically. I want to produce it with the tools or machines that I have available with the laborers that are working on site. If I'm thinking of, say, a material which is like a plywood or a timber or birch ply, then the form would generate different. Like I showed you the ICD and the ITK pavilion, right? Because if imagine it's made up of thin strips which are interwoven, it could still be a shell structure, but then the quality of space would change as against it's made with ferroconcrete, because then that has a different aesthetic quality. We are bringing in light, as against if it's weaving as a technique with wooden strips, then the light comes through slits, like from the, I would say, the voids which are created through that process. So I think that's what I meant when material becomes the driver of the space and the quality, and essentially later on the form that would develop. I could maybe make a long span, have three columns less, so I can have a different kind of an exhibit as against what the gufa has right now. Hopefully, maybe.
See, with respect to the kind of design language that we are trying to practice today, right, and what we are trying to see today, I think the volumes are changing. That is part one. But the biggest problem in our practice today is we as architects are not doing research in terms of understanding the materials. These materials are actually put onto us. They are thrown to us from the market, right? So we are completely dependent on the materials. So we don't think some XYZ person says that this is the material and you can use it for this purpose only. We literally use it for that purpose only, right? We don't even think that if this material can be used for some other factor or not. Okay, we don't think at all. So for an example, the columns that I showed you of a bungalow, the top cladding of the columns, which we did was again the same thing that I said, H40 plus your marble powder mix. Okay. So we never knew that it can act as a plaster material, right? And similarly for the roof that I had done, the whole building, we didn't have a structural engineer. The structural engineer was us only. Okay. There was no structural engineer involved at the beginning. We did the whole building because it was completely parabolic curves. At least today in the market, we don't have structural engineers who are ready to build these kind of designs, give us the details for these kind of designs. So we had to explore ourselves. We have to enter into the execution process, make them understand that this is how the project would be. We build them, then call the structural engineer in place, told them to check out the analysis, do the analysis. Then they came out with a solution that yes, these are possible now. So now the idea is what, somewhere down the line as an architect, we have to take those, those actions, right? You have to start experimenting. Until you don't, you don't become a part of execution, I don't think it is possible. Spans, if you're looking at, right? Every span is possible today. If we are looking at a cantilever thing, we have just executed a table. I'm doing a project just in Borivali. We have just executed a table of a director's table, which is almost 13 feet long, cantilevered completely. Okay. And 10 people can sit on it. So that means structurally things are possible. I'm just talking about one single bench. The roof that you're looking at, 20 thin slab, there were 20 to 30 people standing on it while working. Okay. And it could take those loads. Why it could take these loads is because the MS structure that I had taken as a sheet material, it helped me out in terms of taking the stresses. That building had got columns, but the parking building that I had shown in one of those slides, it doesn't have columns at all. The same 4 sheet is coming down and it is acting as a column. So we talked about load bearing structures. That whole sheet is just a 4 thin cantilevered slab, 4 thin cantilevered slab with 4 different columns, again of 4 thick. All these are possible provided you have to explore it out. You have to experiment. See, when we are working for a college, there are certain possibilities where the college is trying to help out in terms of exploring certain things. But when you're trying to practically work on site, If anything wrong happens, you're trying to experiment with the client's money. If anything happens, we have to build it for them. So when I started my presentation, I said there are a lot of losses that we bore. What happened is, while working on these projects, we realized that at many places we have failed, but we have to rebuild it. Failure happens, but end of the day, we have to rebuild it with our own money. We have to borrow money from the market, get those things in place, work it out, and get the project done. So the whole practice is not an easy thing. See, talking about the architectural practice sitting in some place, it may be very easy. But when you're on site, especially the Twasta thing that you had shown, multiple times that might have failed. The result that you're trying to see is maybe in one photograph. But I think to make that structure or that detail, it was a difficult task for them, for the Twasta guys, right? Because that engineering is not taught in India today. We have to do that research. So those structurally stable things are done with experimentation. And finally, we have achieved to a certain extent, right? The 3D printing, if we are looking at Baumet, Baumet is a company which is in Amsterdam, Austria. Okay. These guys are printing concrete. Within 5 minutes, they are printing a 3 meter structure which is 90-degree bend in this way, right? Within 3 minutes. But the problem is that concrete is costing 20 kgs, is costing 85,000 rupees a bag. 85,000 rupees a bag. Is it possible for us to print that today here in India? That's not possible. But they're doing it. So printing is possible. So exploring things, exploring materials is possible. But sitting in India, practicing with those materials, with the research, we don't have a back support. So hence, we as architects, we have to enter into the execution, do it by ourselves, and then understand. So today I am building a structure which is almost 100 meters columnless. This we are building it in Jamnagar. 100 meters columnless. Possible. Only with metal. It is possible. It is not that it is not possible. But the thing is, we need to have right set of clients. See, we have seen Mumbai airport, right? It's, I think, almost columnless. Large structures, high volume. How do you think that they have built it? There is huge amount of steel, both girders and steel cables on which they have done that, right? Just go to Zaha's building at Navi Mumbai. The execution still happening. These lower panels are open. You can literally see the construction methodology, what they have achieved, how they have made these structural members to achieve that large volume of spaces, right? So everything is possible. It is not that it's not possible, but we really need good structural engineers who can help us out in terms of executing our projects.
Thanks. I just want to now take it a little further in um, two cases, like building from the cultural background that we have of tools and making, the way say most part of India does, with the digital tools, and I think the following machines that we have, like having a 150 machine in house, or maybe customizing your own tools or machines to build things is I would say like a craft. I mean, or it's kind of a new craft that the urban has generated. Or but I would then like extend that context of this new craft then the urban is exploring. Like when you said that you have to keep experimenting, you have to introduce new materials, you experimenting with all of the other of course they have limitation of scale in many ways, but also I think it produces a new aesthetic, a new language. But now when we speak of languages or new forms, it somehow appears in you know I mean not just your work but many other works across the world, that there is a common language that the digital produces. And I think if we start locating that, and if we say look at it in the context of this as a new urban craft or a practice of craft, and the language that the craft is producing, so what are your thoughts on this relationship of the digital tools, the craft, and the context that we are in, and the kind of language that the craft is producing?
Um, so I feel that let me just take a minute to kind of gather the thoughts, because what you said is actually very important. It's very interesting and important, where uh, your digital tool is giving you a new aesthetics. which is creating a language. So now what happens is, say, if the tool is similar across globally, there will be a certain language which every machine will give. For example, 3D printing hai, so it will give you one kind of a language. As again, CNC hai, it will give you one kind of a language. Additive hai, subtractive hai. Each of this has its, because that's a machine language. That's what I believe in, because ye machine ka constraint hai. Now, as humans, and this is where I feel that as architects and designers, we are still the creators, innovators, and the imaginators, because we can create a language which the, so machine gives a language, but if I want to push that language, I tweak the machine. So it becomes like a conversation and a loop with the machine and the human. So there is something, and then I would say that sometimes it just kind of gives you you come across, I would say, you just hit across something which you might have not imagined is possible. For example, like when we were 3D printing at Twasta as a part of the academic project, what happened was it gave us an aesthetic for the wall or for the building or for the, I would say, for a bench or everything that they decided. And we realized that that language is not just visual, it actually became structural language also. So also how we are looking and interpreting that language is also very important. So for example, in studio, as a part of the studio projects we do a lot of say 3D printing on fabric, or we look at kerfing as a technique to start bending wood. So what has happened is this kerfing has given a language to the wood. It has given an aesthetic to the craft. Now what we bring in as a designer is, how do I use that pattern to create a language within the context that we want to use. So for example, if I'm using kerfing as a system to design a table, I will create a pattern accordingly. As against I'm using to create a grid structure, then I will use that language differently. I would use kerfing as a structural language. As against in table, I would use it as an aesthetic language, because the loads, the forces, the function is changing. So machine has its, I would say, set parameters. As designers, we could tweak it, push it, or then I would say use it. Or, and one more thing we've seen is, how do we bring two materials together? So imagine I bring a 3D printed piece together with a CNC'd piece. Like, say, for example, if he said that his machines can cut marble, as against we can also start 3D printing concrete or say wood or biomaterials. And there's also new language which would emerge, which as creators and innovators we can bring on table. Okay, kya hoga if I start interweaving a CNC cut a marble piece with a wooden 3D printed block, which, because each will have its, I would say, the tolerances and the beauty of its own. Like additive manufacturing has those layers. CNC can have that very smooth finish. So, then it's a new language that we are generating for the context we want to build in, is what I feel could be some things we can maybe.
No, no, it's quite nice that you build this picture for us actually. So I mean, we'll hold on to it. We'll wait for his response, and then we will. Yeah.
See, I think today in India, the volume of labors that we have today, rather saying labors, the artisans that we have today, that's huge. But I think in last 20 years, the art that we have been looking at uh, has been slowly lost, right? People who are artisans, they have become contractors or subcontractors, and they started doing simple and easy jobs to earn money faster, right? Especially those artisans who were there to continue the art of their region, right? They are slowly, going away from the subject. Uh, but if you really want to build that or get that thing back again into the industry, right? The machines can help you out, because the drawings are always there. The drawings and the details are always there. Today, by using softwares, you can make those drawings. By using the machines, you can get the finishing done and get the details executed the way the traditional designs and the details were done by hand, right? So we understand that because of the progress and the development, people are changing. People are trying to think that, why should we do a tremendous laborious job? right? The carving details or the marble inlay jobs that we're trying to do, or the small cutting details that we're looking at. If you're looking at the Bidri art that we are seeing, all this is intensive labor, right? So people are not there today. So then who are going to do it? Who is the one who's going to do it? So yes, machines can do it. But if machines can do it, who is going to program those machines? How are we going to deal with them? And can machines deal with multiple materials? Yes, they can. There is a different method to understand and deal with it. So that very important is today as architects and designers, we have to learn the technology to an extent where machines can build the design details and keep that cultural designs and details intact. We don't lose them, right? So these artisans that we are looking at, if we can get them back, because they know how they can be built, because they've done their work with their hand. If we can get them and program them, teach them, tell them to use this technology, because they have got a lot of answers, right? The algorithms are here in their brain. If we can get them back into the system and teach them, which is what we are doing, we're trying to teach them how to run the machine and how a machine can give you back your details. So what happens is for him, when the machine is engraving and he's seeing things, he also comes out with a different solution, saying that, sir, क्या हम इसको ऐसे करते हैं? क्या ये pattern को ला सकते हैं? क्या इसको undulations कर? Things change. Today, what is happening is because of these machines and because of the programming language that we are looking at and working with different materials, especially not only concrete or the polymers that we are looking at, but endless materials which are available to us, whether it is glass, whether it is your PETG, whether it is your concrete that we are saying, or your composite material, especially composite wood that we are also trying to use. All these materials have got their own capabilities of giving us the results. So these people who are lost in the industry, if people are really interested of not doing labor intensive job, but they can be used as programmers, as guides for us to get those designs back into the system, use softwares and get, by using tools, you can get those things executed. So I think we need to know how to use these people. So as architects, as designers, if we have to get back the system into place, I think we have to merge technology. We have to, the gap that we are talking about, bridging this gap. So you have to get these tools and the designers and architects in place and get these artisans back into the industry in a different way, right? That is important, and I look at that way.
For building these relationships about craft and language, and also either reintroducing things that are kind of spread out and not available, or in terms of generating new languages with forms which are already present, or through the means of making generate new forms and new languages. But also I think what point that you made is also the the language would be similar if you have very similar tools. But I think I would choose to maybe think about it a little more differently, because the hammer was the same everywhere. And I think what the people were able to do with it in many places could differ. So I think there is I would say, variation in the input to the tool that is there. And I think that's where the fun part is also.
I agree with you. It's like you give a machine to one person as against you give the same machine to the other person. As humans, I still believe that we have that inherent quality of creating something which is close to us, or which is what we have seen around us, or what we are trained on. And somehow that input goes into the machine. So if you see the digital grotesque by Michael Hansmeyer, and you see the way that project is, it's a similar tool given, say, if it's the same ADM machine or if it's the same CNC machine, but the way also you kind of, like you rightly said, the way we feed in the data to the machine, it also comes a lot from our context, our learning, what does design mean to us, and what is our proposition, and that's what we make the machine do for us. Like, for example, everybody has the same, let me use a simple chat GPT, but the way we write a prompt is the answer the machine is going to give us. It's trained on the same data set, same with Gemini or any Gen AI tool. So that's why we become now prompt architects. So it's similar with, I would say, a machine which is giving us an object or making an object for us.
We will open the panel now for questions and comments. I think we already have the first question ready. Can you pass the mic to Anuj?
Uh, Thank you, Dushyant, for framing this discussion so well. And I actually want to extend from your question, the last question that you asked about the language, and I mean the provocation, and also the last slide that you showed that technology is the answer, but what is the question? And between these two, I was thinking about this through Dushyant's provocation, that actually seeing the buildings generated through computational logics everywhere actually look the same. Firstly, there's an obsession with creating fluid forms. I don't know why every computational form has to be fluid. It'll be muscular, or it'll be some fleshy thing, or folding thing, and that only because, you know, AutoCAD traditionally somehow became everything about orthogonality, or I don't know how. It just automatically hijacked itself into orthogonality. So, is it just the hangover of orthogonality or fighting orthogonality that we are making fluid building and labeling it as computational, because that is the new thing? And and in that, what precisely are we leveraging through technology beyond economy or time in architecture? Because we are still making those containers, we are not addressing, I mean, to take your last provocation by Cedric Price, that what is the question that we are really answering through technology? I mean, yes, we can make buildings cheaper, because in the way Krishna Murthy articulated, does it mean that our future as architects is going to be that the role of this operator of these machines? Because the client will be able to completely design their own machine by clicking a building, by taking a photograph, asking the algorithm to generate a form, work out the internal details. So we are actually that water jet operator. What are we doing in this whole process? So I just want to kind of understand from you that what is the role of architecture now in this computational? Like, I don't see any instrumentality, except that yes, we are just using this medium, we are translating these organic forms which were once not possible to make, or conceivable to be built in architecture, and now we are just making them. We have a new technology, but what are the real questions that we are addressing through computational forms? We have more knowledge about things. We have more parameter. We know that there are more parameters that control any given form, and we keep on tweaking them to get new kinds of shapes. Uh, so so yeah, what is it? I mean, there's pleasure in that, of course. There's pleasure in inhabiting a grassroot or a flower. Uh, but what are we really asking? To kind of go back to your question.
I, f- I feel, okay, now this is my perspective and my belief in it. People might have different stand. I feel that was a phase, or I think that's a one way of thinking where you feel fluidity is equal to computation, because what happens is it kind of breaks away from the notion, like you rightly said, that CAD is orthogonal. And this is what even my students ask me. The first question you ask them, what is computational design? They're like, हमें कुछ organic ऐसा fluid ऐसा जा रहा है ना, ऐसा Zaha type structure बनाना है. But I feel actually that's, we are putting blinders and looking at the form just as a fluid form, but that's not the case. I think if we dig deep into the way the form is built, or what are the systems that went into achieving their form, that is much more, because there's a lot of understanding of, if I want to make a form efficient, the curvatures just are not because Rhino can give me a curvature, but if we see the, whether it's a synclastic, anticlastic, monoclastic surfaces, it changes the way a form would work under pressure. which also when he was explaining his projects, the way you define your curvatures and the way the load starts getting distributed across the form, like these are the examples that we see experiments. If I have a straight slab, as against I start making it ribbed, as against if I make an arc, and if I put the same load, the either I can make it efficient by reducing the material that is going into that structure, and or I could reduce, or I could take a bigger span, or I could take more load. So yeah, these are being done before. So what I feel is that the tool kind of made it easy. So we started seeing a lot of structures. So that is part A. Now I feel in today's time, I can say what I constantly question my role as a designer, as an architect, is that how am I using this tool? Second, a lot of these tools I've also realized are not actually made for architecture. Either they are made for, say, designing aeroplanes, or they are designed for making ships, and we are actually using the tools within architecture. I think now is the time when the reverse is happening. As architects, we are thinking, what is the need of the hour? Like, okay, I want to efficiently optimize the surface area of the building or the cost of the building. And then now there are, I would say, systems and tools which are being made to make the, I would say, the project efficient for an architect and not vice versa. So I think now there is a conscious call which everybody is taking. Of course, there's a set where also there is visualization and people. So I think now there are multiple lenses with which people are looking at computation and architecture. One of it being is sustainability, efficiency, and how can I also reduce time? And these are the intangibles which we don't see, which goes into the architectural process. Like certain conversations that I've had with people in past, it's I am using a tool if I can reduce 1 month of time from the building project by making a firm efficient, by changing certain aspect, it actually makes a huge difference economically. So I think these are also certain intangibles which are, I'm sorry,
Just can I add to what she's
maybe
saying?
did I not understand her
Because I
question?
think no, I think she covered, I think, most of the points. I think the answer probably that you are looking for is uh, the different. I mean, when you started to ask with CAD and the other tools, see, I believe in how much you see is that much you know. Okay, like if you, I keep telling this example. If you take a microscope, you would see much more than just the table. Okay, so when you could still work with geometry which are not orthogonal always. I mean, there were other examples that are, but to process that data was very complicated and time consuming. But what these tools did was it was able to present that data or understanding geometrically uh, to a wider audience or to wider set of architects. So it was not everybody's say interest to engage with geometry in that detail or with that kind of a keen observation. And I think what was skill before, like in terms of sculpting something which is say like a Corinthian order, no, now is where you take an informed decision not to replicate the Corinthian order, but to use that particular curve in ways in that produces the say density that the Corinthian leaves made on that order. So the the way in which we process information now and use it is the difference where it changed to explore these forms. But what you do with it is the later question. So
Yeah, yeah. I mean, the person who was making Corinthian column was also taking an informed decision only. So, and that's why we kind of study it after 2000 years. And I mean, like, what is again this obsession of economizing on time and economy? I don't understand because, I mean, if you were to think of Sagrada Familia, which is like one of the iconic non orthogonal buildings, it just said that let this building be built over the next 30 years. It still continues to be a spectacle. People go to see it while it is still incomplete. It has made the equal amount of money, over its becoming. So what are we really arguing? And that's what my question was, that what are we really, and can we articulate a question around what really can computational design leverage really in order to make society more like relationships, asymmetric relationships in the society in more meaningful ways?
Yeah. See, these things that we are seeing today, uh, I think we are in a different era today, right? We are using different kind of tools which are trying to help us out to build something else, right? Earlier, the design details that we used to see earlier, maybe 1,000 years back, the temple architecture that we saw, every building used to look similar. All the temple architecture buildings used to look similar. Then came an era where the temple architecture that we are looking at are large spaces, large volume of spaces with large volume of blocks and materials. Then came a time where people wanted to build things for themselves, right? Then came these straight lines or those curves, whichever they could build in a very short period of time. The architecture was different. Then came an era where we started seeing these Gothic buildings, the Victorian buildings. Even the Gothic and Victorian buildings are all, everything is aesthetics, right? Internally, the space planning could be rectangular or oval shaped or curvilinear, but everything was about aesthetics. They loved that kind of a style of project at that given period of time. Then came a time where, we as designers and architects and detailers, we started copying them, copying these details, whether it was Indian traditional architecture or the Gothic or the Victorian architecture. We started copying them and started pasting them onto our surfaces, which was just purely aesthetics. Right. This is something which we practiced for since I think almost from 2000, 1900, 1990 to 2000, maybe till the time the computers came in. Then after the computers came in, we got some different kind of algorithms, some different kind of tools with which we thought we can change the dimensions, right? And that's what Zara did. She tried to change the dimension, which we are all fascinated with. We started suddenly seeing different kind of spaces, different kind of volume of spaces. And we think that, as architects, we also want to build that, right? That's what we start looking up to. At that given period of time, when it was 1990 to 2000 or 2005, people thought, let's copy all these Victorian details and, all these aesthetical values, maybe the grills, the cornices, the Corinthian details. Let's replicate that. Even the client for whom I designed that bungalow, the columns, my client always wanted a white house. He wanted the same columns. I had to literally convince him to get these details done. Right. So I had to literally make him believe, make his children believe that this is what I wanted to do. So, when the practice is happening, you're practicing at different eras and different time span, right? And time schedules. And you're also looking at the client's perspective today. Everything that we are designing is for the client, right? We are trying to experiment things on the client's perspective. 90% of the projects that we are designing today, whether it is residential, commercial, interiors, it's all for the clients. So client is demanding. He's got his own set of, notions. Today they come up with Pinterest. We all know that. Google is already, captured all our clients' mind. Now the AI has come in. It's capturing everyone again. So as architects today, what we are doing in today's context, when I'm working with machines, as you said, are we just operators? Of course not. I'm an architect. I think beyond an operator, right? I think beyond an operator. My machines that I'm looking at today, the CNC machine, they told me that CNC machine could only cut metal or engrave metal. No, I can do multiple things. I can use multiple materials and I can get my solutions. That's what I can do. Right. Today, to my client, I'm trying to design hangers for him. I've not shown many projects. I'm designing hangers for him. I'm also designing the rod on which he's going to hang. I'm designing the rod in such a way that there are serrations. He has to keep only 50 clothing into his wardrobe. 51 can't come in. So I'm giving him a set of rules. So it is all design. Right. These tools are not only guiding us in terms of making new designs, but it is also trying to help us out in terms of not just being operators. Today, what I'm trying to do is my drawer. I'm automating my drawer. How am I automating my drawer? I'm just using my CNC guide. On a CNC machine, there is an x-axis. There is a controller. With the controller, I can just tell my A drawer, let us say the A row, A drawer, top one, it has to come out, it has to come out. So I'm trying to use mechanics into it by just learning what this machine is all about. So as an architect, I don't work as an operator. I work as everything. Today, I have built two different machines for my sites, two different CNC machines. Earlier, I used to do inlay at my place. People have to get their marble to my factory. I have to unload them, put it onto my machines, engrave it, send it back to the site. Again, we have to match. When we are matching at certain areas, it doesn't match. Now, what I'm doing is I have made a machine for myself. You take your marble on site, put it late. I'll get the machine on site and do the engraving. Whether it is floor or whether it is wall, I can do that now. So, as an architect, I am taking different decisions. As an architect, I'm trying to use this tool in a different way, not as an operator. Operator can just operate. He can feed the data. I can give him into an USB, which I gave it to you, which you had plugged in there, and we are seeing it. Operator can do only that. But as an architect, we can think beyond, because there are also design calculations that you're trying to do, and you're trying to use what machine can help you out. You're trying to think that this is the machine that I need to use today to get my design done. So architecture is beyond.
Just to clarify, I was
Anu-
saying in future.
Anuj,
No,
can we
yeah, yeah,
also
yeah,
take
yeah.
other
But just
questions
to
if
clarify,
yeah.
I was not qualifying us as operators now, but I was saying, will we become in the future just in the role of the operator?
Like a speculative
Yeah.
Artist who can execute. Today, an artist is just doing a painting or a sculpture. We are going to become those artists who are going to make functional products, functional art, which you're looking at, right? That is what he can do. So, and that's the beauty of architecture. So, I think things can go beyond. If the control of the machines are in our hands, we can think beyond. That's what I feel.
I mean, it just reminds me today we were joking about Mona Lisa, and I think one day a machine will actually paint one of the Mona Lisas. They have no already. So, anyways, any other questions? I think let's take other. So, yeah, we have Ronak, then we have both the Ronaks, and then we have Prasad and Arnav.
Hello. So I'm personally very interested in computational design, computational architecture because, as he said, because I feel like computational architecture has its set of dreams and aspirations attached to it. Because if you think about it, it has a childlike wonder. Because what does it mean to live inside a tree? What does it mean to inhabit a flower? And I feel like computational architecture or software makes it accessible to people, and it has when it is looked at through that lens, it has a different reading of space, and it is different reading of space and a different perception of space. So I think that prevents its meaning being reduced to its banal meaning, that it's just looking organic or it's just looking aesthetically pleasing and filling in the golden ratios or as such. So I feel like computational architecture is accessible in that sense to fulfill dreams or to make aspirations or dreams come alive or to bring them to reality. Also, I was thinking about the what Jinal said, that different materials being used to the design sculptures, make buildings. So there's Neri Oxman, who is an architect and a designer, who produces her works, sculptures, or what her works in biodegradable materials. So I feel like art or design has its own politics, and it is very contextual in that sense. Like computational design is very contextual, because what does it mean to be sustainable, and why is this sustainability often associated with computational designing? Because as we are using biodegradable materials, the designs are itself inspired by nature. They are following the veins of a leaf or the cobwebs of a spider. Like these are being the inspirations to some designers in order to produce their own works. So how does that produce a reading of space, and how is that sort of what trajectory is that taking then from the standard contemporary architecture? How is it different from that reading of space?
Let's take the other questions and we can respond collectively on those. Can you pass the mic to Prasad and Ronak?
Thanks both of you for your presentations. Um, I just kind of, was thinking the way you all were articulating the relationship between human beings and machines, no? Like, and the way what um, Dushyant also said, the hammer hasn't changed, and the way there are, and I'm familiar with people working on power looms. So they use the machine in a very specific way. They have a relationship. There is an industry which kind of builds that relationship. They have friends who build that relationship. They go. The routine is there which builds that relationship. So machine requires that environment to for the human being to kind of build that relationship and exist, and together then they kind of produce. We've been living with machines for last 100 years. Like we use the fan, we switch it off, switch it on. That's what the fridge we open, we close. Something goes wrong with the fan or the fridge, we don't know what to do. We get somebody else to repair it. So that is one relationship with the machine. But the other relationship when you kind of work, and when you in the I was just thinking in the because both of you all spoke about the tools. How do you want to articulate that either that environment uh, or that's psychosomatic, the way the way you use the hammer, like for example, you look at the hammer and you know where to hold it, as a you have a your body knows how to hold it. So how do you want to kind of think about that relationship between the human being and these new machines that are like, for example, even when we all lived through the age of assembled computers, right? So you know what I mean, because when the RAM conked off, we know remove it, put it in. Now with these laptops, if the RAM goes off, we don't know what to do. We take it to the computer center, and then somebody opens it, and somebody does. We don't know that micro system our body is unable to handle. I think the distance between the machine and its mechanics have increased from the body, the more sophisticated they become. The more sophisticated the machine is. The laser cutter, we don't know exactly what is happening in the laser cutter. Like some high intensity light which is kind of compressed and then it is passed through. We don't know how it is compressed. So that as the machine gets sophisticated, the body's relationship with the machine kind of increases, and we don't know how to intervene there. I was thinking, how do you want to articulate that? Because I think a lot of what you're saying is hidden in that relationship of the body with the machine. I think even Anuj was kind of trying to push that idea that how do you want to speculate? How do you want for example, if you were to teach somebody this thing, what will you teach? Will you teach them to assemble the machine, to live with it? Suppose that is the kind of thing. So that is my first question. I have two more questions, but I can ask them later.
I just wanted to comment first before the questions. I mean, the question that you were coming from Anuj, I think there was a time purely during the 2000s, plus or minus 4 years max, where there was a sprite in architecture where they wanted to, ask the questions of what the digital tools can do. And if you see the experiments in that era purely, they were more exploratory in nature. But the bad part or the reason why it comes down to compressing timelines or optimizing structure or reducing material is that was the only justification architecture would give to the corporate and the capitalist economy. Otherwise, we didn't have a frame of reference on how to articulate asking digital question. Like Sagrada Familia could happen only then and because it was Gaudi. Right now, I don't know if any financial institute would, fund a project which is like 80 years in making just to ask questions. It's just that there was a very far collapse, and then we just, as an architects only, we just lost that trajectory to hold the new digital tool. And somewhere I feel that was a miss. Sorry. So continuing from Prasad's comment on the machines, like especially in your presentation, when you say machines could, cut, engrave, print, almost assemble geometries, then what would become the constraint that then produces meaningful architecture? Because historically, I mean, previously, at least in the presentation, we have seen it was shaped by gravity, climate, craft, or material limits. Now, if digital fabrication removes those constraints or morphs them at least, then does the fabrication logic itself becomes the new generator of form?
in that capacity. And then as architect, do you want to deliberately like introduce say conceptual or spatial constraints to avoid a landscape of just arbitrary complexity? And then purely as a broader question, like in many of the AI generated attempts that were shown or the parametric explorations, the envelope or at least the surfaces and surrounding geometries morph dramatically. Like the house that you showed, the interior, or some of those exterior renders which were shown, which were generated. Yet the plan somehow almost remains surprisingly conventional. Like it's still corridors, rooms, cores organized in fairly familiar ways. Now, why does that plan remains so stable, why the outer spatial expressions become, for a lack of better word, say fluid? Is it because the plan is tied to such deep infrastructural logics like structure, services, circulation, fire regulations, etc., that almost resist this algorithmic mutation? And then when we talk about say input, like most of our data sets right now contain mostly modernist and contemporary precedences. We don't have a lot digitized data sets, at least of previous or current, I mean, previous works. And then does that model invertly just stabilize those partial logics as the norm? And then if we have to really question or push the machine, then what kind of spatial culture, say informal settlements, vernacular organizations, or even lived improvisations remain invisible? Because these things are not necessarily documented as data sets. So like when AI learns from past plans, is it learning architecture or is it just learning the geometry?
Yeah, okay, we'll hold now. I think there's a lot lot of questions to respond, and then we'll move on to the others. So, yeah, in your choice of order of responding, yeah.
Uh, you said, I mean, as she said that, one person can hammer it. So let us say that I am handling the hammer. So there is a certain pressure at which I'm going to hammer. If I give the same hammer to you, you're going to work it in a different way. And again, he's going to work it in a different way. If all these three different kind of hammering processes are, the data is calculated and it is brought into the machines, then I can play with multiple iterations and I can get a different project, a different outcome. And that is what algorithms are doing. That is what the machines are doing today. So we need to understand that these tools are not just there to just give certain kind of a pattern only. Number of iterations are there, right? So if I say that there are 100 people out here, 100 people are going to come out with different ideas. I gather all these ideas as a data, put it into the software, come out with a different solution. This is what the softwares are doing. So looking at the hammer structure, I can get different outputs. For every project, I can get a different outcome of the surface that I'm hammering. That is the beauty of this tool that we're trying to use.
I I am of the firm belief that as much as architects enjoy the built form, they also enjoy the act of drawing it because that's what they trained in, right? So it's kind of, for me and for many other people who've spoken before me, actually it's the drawing where their architecture ends. The kick that they get is in there. So I'm asking you whether your kick is in that whole
Yeah,
process of that seeing that thing and making it work, or the build form is just incidental as it happens.
see, long back, I think this was in 2014 or 15. BB Dushi sir was there. So fortunately in my life, he and me, we were roaming in Mumbai for 3 days continuously. Okay. I mean, that was my fortune. And at that period of time, we were just talking to each other. He said like, a paper, a pencil, the hand, all these connected together to the brain. And then we're coming out with an output. That is always there. Even today, it will be there. If it is a mouse pad, and your hand, the keyboard, the screen, that connection will always be there because end of the day, it is you're the one who is trying to design things. Now it is prompt based, right? Right now we are at a prompt based engineering that we are looking at. Things are changing. We need to adopt certain things, but that art is not going to go away. That art will always be there with you. Today, I every project that I do, it starts with a sketch. I do a complete sketch, complete scheme with hand, then it goes into my execution. I've also shown those sketches. Why is it? Because I practice that way. I come from that era. But today, if you are looking at the different generation, right, probably they don't have that much time. They look at things in a different way. So we have to understand their way of looking at things and probably move ahead from there on, right? So that is what we need to do. And think that if those logics can be applied through computation, yes, the outcomes can be different.
I'm saying, understand this. See, we were doing one work in Chennai where there is this whole street called Paris. It's Paris basically, but Chennai people they call it Paris. So it's Georgetown. So basically they used to have these kind of this is 6 years, 10 years ago, I think. They would have two kinds of phones, Korea phone and China phone. China phone are usually the branded phones, the Korea phones were the assembled phones. You can take any damn phone to them, and there are these young men, usually men, there's no women that we saw, no? Who would like to open up the phone and kind of, just have fun with it, look at it. They're not bothered whether the phone is working, not working, whether they will repair it for you and give it to you. If it gets repaired, it's okay. You got your benefit and bonus. But the whole point of them kind of opening it, seeing it, having fun with it, seeing whether they can attach some other element of the phone and kind of reconfigure it to something else. I think that is the figure of an architect that is emerging from the idea of the assembled culture. The assembly culture when you pushing it to the machine ecology, this whole idea. So that's why I'm thinking, what is the relationship between human beings and machines then, because they become a part of each other, producing and manufacturing each other. The 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 form and space and everything else that will emerge will take time and its own kind of thing. I think it's that in that phase of them building themselves up, a new culture gets emerged. I think we should look at
Today,
that.
today, how many institutes do have these machines and how many people are there ready to open these machines and work with them and understand these machines? Exactly. See, it's very simple. I have a machine operator. I've got 3D printers in my office, 80 of them, of which only 22 are working. Rest are not working. I'm dependent on my operators, telling them, yaar, isko theek kar. Right. The day I said, Garima is working with you. Garima is studying in their college. Okay, she was my intern. She works on 3D printers. One fine day she comes and says, Sir, एक ही machine चल रहा है. I said, what are you saying? एक ही machine चल. I took her. We both sat together. एक machine open किया सुबह से शाम तक. We made 20 machines working because I know how to work with them. Very important is, you as an architect, are you ready to spend that time on the machines, or you're just looking at ki baba, I just want to make drawings? It all depends whether you want to make your hands dirty or not. So today for me, I can build a CNC machines. I know everything. My operator just left, my 3D printer operator just left my office saying that sir, आपके पास bamboo lab का machine नहीं है. हमारे machines पुराने और slow चलते हैं. No, what are you saying? And he left. And then my HR comes, she comes and says, sir, वो लड़का इसलिए चला गया कि हमारे मशीन स्पीड से नहीं चल रहे. मैं बोला, is it? I said, come. I went into the machine operating system. There inside that post processor, I had to just change from 1:1 to 1:10. That's it. And my machine was working 10 times faster. And nobody knows this. And the same machine is working. I don't have to buy a new machine, because the new machines which are coming in, everything is working with programs. You have to program it out. The tools are the same. The mechanical tools are the same. I will have a bearing, I will have a guide, I will have a nozzle. Everything is same. Who is giving the commands? The operator is giving the commands. The operator has to understand how to operate the system. If I'm aware of that system, it is very good. I am aware of it. Since I've been working since 2006, and I literally didn't have people who can help me out in terms of getting these machines intact. So literally I had to open up each and every tool, each and every system, work it out. I learned it a hard way, right? But in today's context, if the colleges can tell them that, chalo, हमने आपको ये machine लाके दे, उसको open करो और refix करो. Let's understand. Is there a college doing this? They are not. So that's the loss. That's the loss. Now coming to his question saying that, the skins are fluidic, the outer surfaces are fluidic, but internally the plans are conventional. Why is it? Because in Indian context, if you're looking at residential buildings, 90% of the developers or 90% of our clients, they believe in Vastu. Understand one thing. The Vastu is playing a major role in our life, in our architect's life. And that is where we are going wrong. I have made one building which I have not shown here. It's completely fluid, organic. All the surfaces are everything is circular in form. Okay, the planning was completely in circular spaces. One fine day I was sitting with my client. 1 month, sorry, 6 months, I was designing this whole thing. Then the presentation happened. Suddenly the client says that, I've got a Vastu guy coming in and you have to show it to her. So 1 hour, this lady, she was eating my head, telling me these are all circular spaces. The whole thing is a flop. You can't design this. Fortunately, their kids, the client's kids, they're young enough. They are 25, 30. So they love Zah's projects and all. So they came there inside during the lunchtime and they said, Sir, आपका presentation final हो गया? Project okay है? तो I said, यार, इसने तो मेरा blood pressure बढ़ा दिया. है ना, मेरा पूरा प्लानिंग चेंज करना है. 6 months I worked. I have to change everything. क्या सर क्या हो गया? She is saying ये प्लान पॉसिबल ही नहीं है. Now this guy says, मॅडम काय झालं? काय प्रॉब्लेम आहे का? हा सर्क्युलर स्पेसेस चालणार आहे. मॅडम आम्हाला हाच प्रोजेक्ट पाहिजे. वी डोंट नॉट चेंज. मला असंच पाहिजे. तुम्ही ह्याच्यामध्ये वास्तू टाकू शकता का? दिस इज व्हॉट ही सेड. Now this lady, इतने देर तक the ball was in her court. Now I am like, यार मजा आ रहा है अभी कुछ, मेरी जिंदगी में सफल है. Now this lady says, हाँ मी बघतो. And you know what? Lunch खत्म हुआ and त्यांनी बघितलं. And the outcome is there. What is the outcome? वो सर्कुलर फॉर्म के अंदर शी सेज स्लैब कास्टिंग के वक्त स्क्वायर फॉर्म में कॉपर का पाइप डालने का. And the vastu is scattered. Now what do you say this? So this, we are in that situation today. We have got clients who believe in all this, but we also need to have right vastu guys, because every client comes with a vastu consultant.
So I have a thing to add to this. I'm tying two questions. I think somebody asked the question of efficiency, and I think you also mentioned, or you mentioned, and also Ronak's question. I just want to draw it in some way. I once asked a person who I knew I was doing a project for. I said, "Agar Vastu say, if Vastu would solve everybody's problem, and if India is using Vastu everywhere, everyone would be equally happy, or equally rich, or equally successful." So, and the second thing, I think somebody was asking the digital and computation, if it's making everything efficient, why are we not using efficiency? I mean, in some ways, but I think there is I mean, I'm being sarcastic with that relationship, but also trying to kind of open up. There are some gaps, and we are kind of working on those gaps right now. So I don't want it to be opened in some ways or the other. And I think the form that you're talking about in terms of why do we, or what does it mean to inhabit a space which is replicating or which is kind of similar to other forms? I think we still inhabit those. I mean, why don't climb a tree and just be there, or become a tree house, or the other is that we have never come across this space that we inhabit on an everyday basis, and I think somebody else was saying that we are used to the rectangular space, and I think that is one way where when somebody encounters it, when someone sees it or uses it for the first time, I think we are still transitioning in some way or the other. And if you don't, and I keep saying this, that if you don't know the tool, you will be a monkey with a gun or with a whiskey. So both are catastrophic in some ways or the other. So I think we are still trying to do that. We are still and anyways, I think that we'll just end it there.
So to
And
add one more
yeah.
bit to something that you said about us staying in rectangular, like predominantly our plans are square or orthogonal or rectangular. I think somewhere when the AEC industry shifted to making beams columns through casting of concrete, it was efficient to construct it in straight lines. And since so many years, the AC industry hasn't changed. That is the reason why I believe that we are still having all the plans which are orthogonal, and because of which the data sets, if you see in Kutch, the Kacha houses that were made, they were always circular. You don't like, there are square, but because then the method of construction was different. So you could try different forms. Right now, if we see across globally, the way we build our buildings are through casting of concrete, be it whatever kind of formwork we use. So that is the reason why what happens is the easiest way to make a formwork is usko 90-degree bana do, ya max a 45-degree, or it's at an angle, because it's the method of construction, I believe, which gave rise to the kind of internal spaces that we inhabit. And because that has been so long, say 50, 100 years, as humans, it's now engraved in our DNA to live and associate ourselves with such spaces. So I think that is the reason why even the new forms that are being made, I think it's psychological and the way we are constructing. So I think that could be, I believe, one of the reasons, and that is the reason why all the data sets that are being trained, we always look at, like acha 3 by 5. Also, those, I would say, those parameters are also constrained by the construction technique. So, like how you have fabrication driven designs, in real world, we have these construction driven designs and efficiency of using a system, which is what is giving rise to the kind of projects we live in.
Okay, one last thing that Arnav and Rupali, and then we end. That's the time we have for today.
Um, Something that Anuj and I guess Ronak Prasad also spoke about, and I'm still struggling throughout our series about what architecture exactly is. So I was thinking, are we the tools that create something, or one that, or we are the creators or collectors of that tools that are designed to create? Like when I look at the presentations that we saw today, made me think in a way that we are somehow creating those tools. And also I'm thinking this in two ways. Like, is it is it the designer's ego or bias that stops us or strikes us that this is somewhere wrong or a joke to think that Autodesk Forma or Finch would create a plan layout for me? And like, why does it strikes the morality that we say we believe? Or in the second way, I'm thinking it as, is it also because that I've been observing like these digital tools are only constrained and constricted to the idea of what we see or the visuals, and they are not efficient or capable enough to create an experience.
Uh, can I take this? So I mean, it's a it's good that you bring out this vulnerability, this thought that is going on in your mind, and I guess I think at some point many of us go through this thought, and I would suggest you very strongly this book we have in our library, Are We Human? And it exactly explores this question. I think that you take, more than the panel, I think that book will help you with a lot of time to gestate this thought and also process it further. Okay, so can we move on to Rupali? Thanks.
Yeah, I know. Thanks so much for this presentation. Following some of these questions, I'm just thinking of actually what Ronak said, uh, where does the design come from? Does it come from a certain justification that one has to build? Because today our clients who are paying are corporate clients, right? Like, and somewhere we have fallen into how do you justify? Then it's the language of efficiency, right? The language of um, vastu, is selling to justify projects. So I'm just wondering if the digital is able to produce a spatial language. Are we missing a spatial theory to speak with, which can then start justifying a certain way of inhabiting, living, right, dreaming, where space somehow is back into the equation, because otherwise everything that we are speaking with is outside architectural space. It's efficiency, it's whatever, vastu and other things. So I'm just wondering if the digital is able to produce another kind of language, a spatial theory to speak with. So I mean, just kind of throwing that open.
See, looking at the digital aspect, yes, it can. It depends about how much, with what intents you want to work with, right? Long back, I think in 2010 or 12, we designed one building, a residential building. So where we were supposed to design 2 BHKs and 1 BHKs. Okay. So we came out with a proposal saying that, we will not build walls. We'll just build the external walls. Internal walls we are not going to build. And we're going to sunk the whole slab. We're going to sunk the whole slab. Now let the client decide where he wants his washroom. And let the client decide where he wants his kitchen. If he wants a bigger living room, no bedrooms, and a small kitchen and one washroom, let him decide. A 2 BHK space, let us say 900 square feet, yeah, 700 square feet, yeah, 500 square feet. Let him design. So what is happening is, if it is a 10-story building that we have designed, and with 50 tenements, 50 apartments that we have to design, I'm having 50 different solutions. Every brain is thinking in his way, which I'm giving as an architect, giving the opportunity for him to build his space. Right. So that is something which we try to do by just sunking a slab, because what happens is, if I fix my toilet space, then I have to build the toilet there only. The waterproofing has to be done there. The pipeline has to go from there only. I don't have an opportunity. So if the whole slab is sunk, so I can put anywhere, right? The wiring can be done from anywhere. Piping can be done from anywhere. But end of the day, I fix my duct space. My piping has to go through that space only. So there comes the service factor. So it all depends upon how you're tackling your project. That matters. So as architects today, I think with this digital tools, we have bigger opportunities which has opened up, right? If today, with the help of digital tools, I can reduce the volume of the concrete of this beam, it is possible. Structurally, 100% it is possible. And I can also detail this out in a beautiful way. I don't need extra aesthetics to it. This whole beam could have its own aesthetics, reduce the volume of the beam and get my design intact. Possible. So digital tools give us those opportunities. It all depends upon the architect's responsibility about how much time he wants to spend using these tools and how these tools are going to guide him to give new iterations. So that matters. So end of the day, it is all about an architect and his vision, his dedication, understanding the tools, whether it is technical tools as I'm working with the machines and the softwares, or only the softwares. It all matters upon how you are thinking, right? One fine day I got an architect who comes out with a design and says that we have made, and she's from A, and she says, I've made all my fabrication drawings. You have to just cut it and give it to me because you've got machines. I said, okay, send me the drawings. She sent me the drawings. There were 150 sheets in which she laid all these things, and she wanted me to just cut this thing and give it to her. I said, okay, I charged her for 150 sheets. End of the day, I completed in 72 sheets, the whole project. So I saved with so much amount of money, right? I could only do that because she was fixed with the parameters of the nest fab which was giving her. But I knew how to play with that nest fab, with the post process, and get it more optimized. So it all depends upon how you are putting or pushing your boundaries using these tools. That matters a lot. Yeah.
So there is this book Emergence, which I had read while I was doing my thesis, where we talk about swarm intelligence, where each player in a situation is contributing to the kind of space we build and the kind of relations we build. I also at that time did a case study on Dharavi, that how Dharavi emerged over time So the space was not a top-down approach, but it was actually a bottom-up system which emerged over time. So I have seen, like, at least I know we have tried. The unfortunate part is that we've not been able to adopt it for a real world scenario, but say within a studio discourse, what we've done is we've used these multi-objective optimization tools where you construct spatial logic through understanding of systems existing in nature, because nature has the most efficient systems in all terms, be it material, structure, spatial, all of it, like the way a termite will build the nest. It's not just structural, but also the way the entire the interconnectedness is, that it always stays cool. So the thing is, I think, yes, digital tools does have the, I would say, the efficiency to bring those kind of, I would say, frameworks to build new spatial relations, but I also feel it kind of doesn't get, it just stays at a conceptual level also because of the kind of ecosystem we are in. Kalutke, if you want to build a house which is because I remember I'd done a thesis where the entire, I was looking at low cost housing within Mumbai because of the quality of the light or the quality of life that those people have. So it was based on the logic of cellular automata, and I developed a new framework. But also what happens is when it comes to constructing it for a real world application, then there are some other challenges in terms of the rules, the regulations, the way things could be constructed. So I think that is the reason why also then we kind of dial down, or we kind of dumb down the idea, the conceptual idea that we started it to, say, kind of trying to bridge getting new spatial relations, but then still looking at what is feasible within the actual context. I think that is what I have seen, that there is a huge gap between what we can do within the academics to what actually, and I'm talking about now building architectural forms and spaces which people would inhabit. And then there is that gap where unfortunately we are not able to get those. And somehow there are, like Sameep has done some projects which actually brings new way or new way of living by the way the form is constructed. But I think it's just very less. The percentage is very less, is what.
So,
See, I think we're in that transition stage right now. So, we're not ready to believe, and we are not even ready to accept it that yeah, chal karte hai. Let's put that first step and understand. Let's go ahead. Karte hai na. 10 log fail hoga. Kya farak padta hai? That question is something which we have to ask. Let's fail. We're going to learn, right? End of the day, at least 80% of the project will be done. Now 20% will be a failure. So why are we not looking at attempting those thought processes into our practice? So it's a question that we always need to ask. Chalo yaar, let's do it. Let's play with the materials. Let's work with all the opportunities that we have got around us. So the softwares that was done, or these machines that were built, as you said, they were for automobile, aeronautics, shipping. Why were they for them? Why not for us? We are the largest industry in the world. They should be for us, right? So the day we ask this question, that why these machines are not belonging to us, and why these are not taught to us in our colleges, how to operate them, what is the output that they can give, right? Because as designers, we should know what is the end outcome that these machines can produce to us. So accordingly, we can start manipulating our details, right? The details that we are talking about, nature is building its own structural details. What we are trying to do is we are trying to adopt that, we are trying to learn that, and put by using softwares, we are trying to make these structures in a different way right now, right? So we have to put that first step and start saying that, chalo yaar, I mean, we are not late, right? We are always thinking that West is doing something else. We are not doing anything, we are just copying it out. Why should we copy? Why don't we invent something? So you as architects and designers, I think we should come together. मैं तो बहुत बार ये बोलता हूँ कि lectures में, why can't one studio of 40 students together start one office? Right? All those 40 students will have their own capabilities. कोई FSI में अच्छा रहेगा, कोई planning में अच्छा रहेगा, कोई execution में अच्छा रहेगा. Why don't you become one team? Why do you need people? मैं एक ऑफिस होके मैं लोगों को ला रहा हूँ, 10 आदमी काम करता है, 4 छोड़ के जाता है, 6 छोड़ के जाता है, एंड ऑफ द 2 रह जाते हैं, right? Why can't this 40 students together make one office when you come out, right? You can have your own projects. Every architect 10 लाख रुपए डालेगा तो है ना 10 करोड़ जमा कर सकता है. and he can build his own project. Why can't you do that? But we are not ready to do it क्योंकि हमें वो सिखाया नहीं गया है. That's the biggest problem. And we think individual architectural practices ही होते हैं. That is what we do. You know, जो ego you said, that is the problem. The day we kill this ego and come together, probably we can see that change, you know, which we are all looking at now.
Thanks. I think we are a lot of time, and I think we'll take this last comment. And I just want to conclude it in few to like 3 sentences, not more. Just stop me before if I go longer. I think that that India, and I'm just placing it in the context of the like the global south or the developing countries, and the technology is always a defining factor for any place to be identified as rich or developed or successful in many ways. But I think technology is not located there, and digital doesn't locate itself in that context. And I think it's far beyond or far spread out rather than just kind of narrowing it down in how much, how well, how efficient, how fast you can do things. And on the local or I mean in our everyday lives today, I think we are kind of stuck, or we are in the fatigue of the efficiency or the efficient, or we are stuck in the fatigue of how fast we can do things, or how much we can optimize it. And I think the production of space or the production of architecture is coming from that fatigue that we are currently placed in, and I think in all forms. But also identifying that the digital tools are also providing a certain play or an opportunity for us to sort of rethink this mode of working, because it doesn't allow us to slow down the way that other forms of practices allow us to do so. So I think that maybe it's time to kind of also re-question, rethink, open up new things for us to engage with this in our own ways. And with this, I will conclude the session for today. And thank you both of you to share your thoughts. So. And I will invite Anush to sort of close the series.
Thank you. Sorry, I'll not take too much time. I'll just take 2 more minutes, and that's because this was the last session of our, marathon of symposia that we did under contemporary architectural practice in India, a millennial archaeology. And I think I mean, just to recount the intent behind doing this is that we hope to make this like a concentrated effort to reach out to the practitioners out there and understand what are the real things that happen on the field, because sitting in classrooms and talking about their works as objects of learning, we do not know what actual things go on in the ground. And I think this series has given us an opportunity to connect and reach out to so many people working on the field and actually learn the real things in a much more intimate manner of conversation. And having said that, I also want to acknowledge that we have been able to only reach out to largely people from Mumbai and a few cities around us, but this exercise will definitely kind of continue and grow. The second thing that we wish to do is also to treat these as chapters which can be developed into more sustained kind of inquiries or histories that can emerge. And having said that, again, I'll say that when we started planning this whole symposium, we came up with 16 such chapters, which became 14, and we could execute only 11. So there are a lot more issues and kind of these thematics under which we want to kind of extend this study. And lastly, we wanted to engage the city in these discussions. A city in the sense that it was an open kind of course which we wanted to invite, and I think we'll need to do a little more strategizing of, I mean, one is that all these lectures are there in the public domain, and people are going to kind of look at the questions that were raised and expand these questions. But probably these can also be taken as, modules which can be fleshed out further and kind of sustained in more discussions. So with these three things, I'm very happy that we have done 11 talks, inviting more than 30 practitioners on this table, who are joined by my colleagues at C, who helped me in moderating these discussions, bringing out and raising very interesting questions, which kind of, extends the legacy of first questions itself, that asking and interrogating the what is happening in the practice again and again. And lastly, I also want to thank complete help by our technical team, Udayan, Yuvraj, who have, so gracefully set up this very professional relationship, and kind of energize this space with all the things that will remain as legacy for our school. So thank you so much, and it's really nice to have all the students in this room, because there's a completely renewed energy when you are around with discussion of architecture. So thank you everyone, and we'll see you in the next season, which will be